second day of Cloud Native Rejekts in London. We have such a beautiful weather also this day. My name is David, and I have the pleasure to open up the Waterloo track this morning. And yeah, so after a short technical issue, we will have Piotr Jablonski, who is going to tell you about a secure mesh, and I welcome him to the stage.
Yeah, thank you for having me on this session. My name is Piotr Jablonski, and I'm a Senior Solutions Architect at Isovalent. Right now at Cisco, because Cisco acquired a year ago this company, but my duties are roughly the same. So I'm involved as an advisor to the projects around networking and security, Cilium, Tetragon, and other stuff. With Kubernetes, roughly 20 years plus experience in the IT industry, around 4 years in Kubernetes. I'm avid rower, 2,000 kilometers per year, so I'm trying to stay active. Today we are going to discuss specific security challenges around service meshes. Service meshes itself provide security for application layer, but we cannot forget that every solution should have a complementary security parameters and measures, because alone it can impose the risk from the different vector perspective. So here are 10 typical threat vectors for service meshes. We will touch today directly or indirectly these 4 of highlighted ones. So compromised application containers is one thing which is the most crucial thing you need to focus on, because vulnerabilities today and exploitability can be easily injected into the container through the code, through the CI/CD pipeline. I'm not going to talk about this, but rather about networking perspective, how the architecture exposes vulnerable parts of service meshes, and security of the control plane is one of them. You will notice that every service mesh architecture is actually quite vulnerable in terms of exposure. And what is combined with security and control plane is denial of service, which means once the control plane is exposed, you can attack this through the chain of attacks on the resources, on the open ports, and I will show you how you can actually do that. I'm not asking you to do so in your environment, of course. I'm not teaching you to do red teaming, but otherwise you won't be aware what to apply in your environment as a countermeasure. And also last year at Confidence, I presented how Istio security policy can be breached through the chain of DDoS attacks, or not DDoS, DOS attacks. That was on the previous releases, so no worries, this is patched already. There was no official vulnerability for the attack which I presented, because Istio maintainers mentioned that it's alpha code, so no vulnerability is needed. And also the last point is policy enforcement gaps, which is how to provide network policies to fill the gaps in your architecture. So every countermeasure should be prepared against specific architecture. We have 2 major architectures for service meshes, sidecar and sidecar-less. Linkerd, for example, architecture is a sidecar example, sidecar-based example, and to provide right policies, you need to know how this architecture looks like. So you need to know what are the ports, how the communication looks like, and what are the exposures in terms of IP addresses. What is interesting, if you find if you do searches across the websites and in the internet, you will not find the IP addresses which are exposed Of course, IP addresses are assigned automatically, but at least the control plane should be presented in a way that you should know how to protect with your network policies. This is not like that. You need to discover by yourself, and I think this is quite a big weakness in building our awareness in terms of security of service meshes. So I did it by myself. Of course, this work is not completed, but I will show you specific examples of Istio ambient mesh, which is example of sidecar-less architecture, where control plane is also exposed to the DOS attacks. For example, would you be expecting that Z-tunnel, which is aggregated proxy instantiation of proxy which has been moved from the pod to the host, it's reachable by any application pod? Would you expect that? I wouldn't. Even if you apply authorization policy, actually all the control plane pods from Istio are reachable. So if you apply authorization policy which forbids for the traffic going outside of the default namespace, all the default namespace application pods can still reach via ICMP or UDP or TCP traffic all the control plane components, including Istio-D and Z-tunnel. Of course, this doesn't mean automatically that you can maintain or provide successful attack, but you can try. You can try, and you can try it more. You can send TCP SYN flat and observe how many half open connections are utilizing or saturates memory. Maybe not, maybe yes. It depends on the implementation. Question to you: how do you think service mesh can block any of these, or which one of these can be blocked by service mesh? Either service mesh authorization policy or specific architecture. How do you think? Any of these can be blocked by service mesh authorization policy or any other security things related to service mesh? Actually, as it occurs, none of them. What does it mean? It means that you can use straight away techniques, network techniques around these protocols and DOS mechanics to attack control plane and attack also application which are part of the service mesh architecture. One of these is anti-spoofing. Anti-spoofing is very important nowadays to protect your service mesh. Service mesh itself cannot protect itself and cannot provide anti-spoofing by itself. So you need to provide in your environment, and this is crucial thing. This can be provided by the Linux itself, because by default RP filter, which is checking the validity of source IP, by default source IP should, or the packet with source IP should come via the interface when we expect this IP, source IP, through the routing. So we are checking our routing tables, and if in the routing tables this source IP is expected to be transferable through this IP, through this interface we receive the traffic, then the traffic is accepted. We can change this reverse path for filtering to accept asymmetric traffic, so we can change the parameter to 0, but then anti-spoofing doesn't work. What to do then? Then you can apply the CNI with the anti-spoofing. So for example, Cilium is having anti-spoofing by default. You cannot turn it off. And anti-spoofing is very important because through the spoofing I successfully attacked Istio 1.5 years ago by sending the traffic and pretending to be someone else. So I send the traffic, pretending that I'm Z-tunnel or Istio-D actually. but I wasn't Istio-D, I was just an application pod. So this nowadays, Istio is also hardened, and even if it's not hardened system, you should still provide anti-spoofing in your environment. This is a zero-day job and very important in terms of protecting your not only service mesh but any other infrastructure you have in your environment. I'm focused on Istio, but it's not, the disclaimer here is that Istio itself is very well protected, of course, and the hardening is improved a lot throughout the last months. My intention here is that my projects are related mainly around Cilium and Istio, so that's why I'm focusing on Istio. But don't take my words as a discouragement of using Istio. It's not like that. I'm encouraging you to use something more apart from Istio to protect your environment. So let's see this in a demo, which is a bit complicated stuff because of a resolution of this between my laptop compatibility and the screen. But let's see. In the environment, I'm using two Istio policy authorization policies. One of them is listed here. So essentially, this is very simple policy. In the default and app, this is for default namespace, and any source from the same namespace default can connect only to the resources within this namespace, okay? Within default. There is another namespace, application, app, and also the same equivalent policy is applied for the app namespace. So pods in the app namespace can communicate in the app namespace, and pods in the default namespace can communicate in their own namespace. This is my expectation here. So we are starting from the environment where we have on the right-hand side my source pod, which I will use as a attacker pod, and this is located in the default namespace. And on the left-hand side, we have a product page from the book info standard application, which is deployed in the namespace app. And as you can see, zTunnel or Istio's ambient mesh is causing that there's no sidecars within each of the pod, but there is a straw. This H-bone is like a straw, is the socket connected to each pod. And the traffic, which is related to HTTP. So HTTP traffic is triggering authorization policy to be verified. Not TCP traffic, not UDP traffic, not IP traffic, HTTP traffic. So then, if I'm trying to send the traffic from source pod to the IP address of the product page, which is 10.244.187 on the port 9080, the status is unauthorized. You can see the status on the zTunnel, and the traffic is simply not allowed. Reset flag in the TCP is sent on behalf of the product page by zTunnel. And the first kind of attack what you can provide in the environment is the TCP SYN flat. And from that perspective, let's see how it goes. Hold on a sec. Okay. So here is the environment. Let me increase the font. Maybe this will be helpful. Here is the product page pod, and in the bottom right corner is my pane for the source pod. And from here I will start my script in Python. Python is very useful stuff for those kind of attacks. And I will do the TCP SYN flat. TCP SYN flat, and how to verify it. Can you see it in the zTunnel? Actually, zTunnel cannot observe partial or any traffic which is not related to HTTP. So if you establish even a TCP connection or do the TCP synflat, zTunnel logs will not inform us about this kind of traffic. So where we can see this traffic, we can observe it in the Hubble, for example, of Cilium, or do this TCP dump on the host level. This is the level where we can operate. So let me jump to the, for example, Istio, Cilium on the control plane here, and do the Hubble observe. So this is some packets caught, and TCP synflat, as you can see, provides a lot of packets sent to the application pod. Is it dangerous? Yes, this is definitely dangerous because this is consuming resources. Is it equal to the successful attack? Not yet, not yet. Of course, there are many resources which are available, so this is not equal to the breaching or reading sensitive data, but this is the beginning. Starting from here, we can start, for example, trying to establish connection with the application which is there. Of course, on the TCP level, as I mentioned, this is possible. So if I use another script from written in Python, which is establishing the TCP connection, long-living connection. I call this script as a long-living connection. You can notice, or probably note, that the status of this connection is connected. And right now, TCP sequence numbers are appearing in the list. What does it mean? It means that the TCP session is sending keep alives to keep the connection active. This is pure TCP connection. It's not HTTP. Is it dangerous? Not yet. Is it equal to the breaching of the policy? It's close, because what we need to add is just to HTTP layer. But once I add a HTTP layer on top of TCP connection, zTunnel comes to play and blocks, sends the reset flag, and the connection is dropped. But why I'm sending to you this way of establishing long-living connections? This is quite useful stuff to attack service mesh, because, for example, Istio is respecting the existing connections already. So if you have long-living connections before the policy, Istio policy is applied, those long-living connections are allowed to exist between resources which are already forbidden to communicate. So, of course, after a while, maybe after a specific time, it's possible to detect that such long-living connections, but from my experience, when customers are sending us sysdumps or for troubleshooting and analysis of their environment, we find always some long-living connections. What they are doing, not many people know. So building awareness what those long-living connections are existing for is very important, because they can bypass Istio policy or service mesh policy. All right, so long-living connections is a quite dangerous thing. What else? Okay, I mentioned that I cannot breach the policy, but how can I bypass? Is there a way right now for me to somehow connect to the product page? Because right now I didn't show it to you, but if I do curl on the IP address of the product page website, I'm not allowed. So the font, of course, is very small, but let me increase it. There is an empty reply from server for the curl sent to the application pod. This is due to the authorization policy which does not allow for this traffic. By the way, in the middle pane, you can see both authorization policies applied. So hopefully on the recording you can see this in a better resolution. But still, what we can do with that? Can we bypass the policy? The answer is yes. What are the conditions or prerequisites to do so? You can simply build the tunnel. So this is the way of bypassing. Because, as I mentioned, Istio, or generally not only Istio, but Linkerd or service meshes, do not inspect other type of protocols like UDP, ICMP, or tunneling protocols like over UDP, over DNS, which is also in major cases UDP traffic. You can tunnel the traffic. Thank you. So let's introduce our additional guest in the middle section, which is proxy pod. As a prerequisite, this proxy pod, of course, should have something which can terminate our tunnel. If it has such a code, if we successfully injected such a code which can terminate ICMP or UDP tunnel, we can access the application through the HTTP even. So what is the mechanics here? Instead of going through the H-bound socket, we can send the traffic over ICMP UDP because zTunnel does not inspect this kind of traffic. And the data path is normal for this kind of traffic. So either through the eBPF code or whatever. And we are sending this ICMP UDP, which is terminated on the proxy pod. And proxy pod decapsulates this traffic, exposes HTTP packet, and what it's doing next is forwarding the traffic to the application. Of course, this is additional prerequisite here. Proxy pod should be within the secure zone. So proxy pod is within the same namespace as application in this case, because then we can bypass or jump over the fence of the Istio authorization policy. So let's have a look. How does it look like quickly? All right. So for this purpose, I will jump to the proxy pod, and on the proxy pod, I need to have some code to terminate ICMP UDP. It doesn't happen automatically, so of course such kind of attack is not available day one. We need to inject something, but once we do TCP proxy Python, UDP HTTP relay. This is the script in Python. Again, either ICMP or UDP, whatever, the same effect. And from a source pod, I will launch Python 3, and then HTTP over UDP, this one. As a result, as you can see, there is a HTTP response with the website. We can see that there is this is the website from the bookstore application. And of course, you may think that I'm connected to the different pod, but of course you can do the TCP dump or capture the traffic and prove that actually this traffic is captured. I mean, the HTTP website is downloaded. So yeah, I did it also for this kind of traffic, and and for UDP it looks like this. Okay. So here is the UDP HTTP traffic transferred over UDP. It's not decoded automatically by the Wireshark, but as you can see, the UDP datagram protocol is on the port 9080, and within data there is the HTTP website which can be decoded. How? You can right-click on the data and do show packet bytes, and voila, we have website which is exactly the front page of the bookstore. So either ICMP UDP, it's easy to provide the over-the-fence jump to the security zone provided by any service mesh. So as you can see, it's easy. What can you do against that? Please focus on the key aspects of the protecting service meshes. So shift-left security, this is the one main component. Fast wins is to provide network policies using namespace boundaries, block unused protocols, including IPv6, take control of DNS and filter FQDNs. In the long term, please take care of shift-left security. So it means take care of your packages, programs, code. As mentioned yesterday on one of the sessions around SQL injections, around 20% of your code is infected statistically. Maybe not exploitable, maybe not vulnerable by every attacker, but anyway, please take care of these aspects so your service mesh can be complementary, protected, and provide its own service in a good, expected way. Thank you.
Yeah, thank you for the talk. I think we have like a 5-minute break before the next talk begins.
right. Hi there, everyone. My name is Nitish. I work at Acuity as a software engineer. So this is a generally talk about introducing Argo CD CLI functionality with plugin support that eventually lets you build your custom plugins for now. So before we get started, let me just quickly give you an introduction about myself. So my name is Nitish. I work as a software engineer at Acuity. I'm also an Argo CD maintainer. I'm a CNCF ambassador. I did my LFX with Kubernetes project a couple of years back, and you can find me at all platforms at the rate Nitishbhai. And I'm also finally an undergraduate. So I'll probably be graduating in next couple of months. All right, so let's get started on this. So this proposal regarding adding Argo CD CLI plugin support, it was added by Christian Hernandez, which eventually lets you, build some sort of plugins to your Argo CD CLI. So that you can extend CLI's functionality without depending upon, without basically you going into Argo CD's code base and raising some sort of PRs to introduce your own subcommand. That's not what you need to do right now. So that was generally basically the proposal that was raised. And you can obviously scan that, you can see what was the motivation behind, adding this plugin support proposal. So let's get started. The first question that comes is, what is an Argo CD plugin? So you can think about Argo CD plugin concept similar to how kubectl has a plugin interface actually. Just want to know how many of you know the kubectl plugins here? Just raise your hands here. Okay, so for all of those who doesn't know about the kubectl plugins, it's just a way to extend your kubectl CLI's functionality that eventually lets you introduce your own subcommands without you going into the kubectl's code base, making changes there, raise a pull request, things sort of like that. That's what is a similar thing that we're going to do with the Argo CD. So if you want to have your own subcommands introduced to Argo CD, a normal process that would involve for you is to go into Argo CD's code base, make changes there, add your whatever the things, raise a pull request, and then the maintainers are going to go through the feedback, and then you're obviously going to have your PR get merged and things like that. But with the plugin, it's like all you need to do is build your binary, put it in your path, absolute path, give it a specific name such as Argo CD hyphen, that's a prefix, so that it can differentiate that, okay, this is a specific plugin related to Argo CD only. And then that plugin is basically going to execute as a normal subcommand of Argo CD. So example, if you see Argo CD demo plugin or Argo CD demo hyphen plugin is a valid binary name, which we will come to that. But what is an Argo CD plugin for now? It's basically a simple standalone executable file whose name actually begins with Argo CD hyphen, and it's going to actually reside in your system's absolute path. Now, the second question that comes is, what are the conditions for an Argo CD plugin? There are only 3 conditions that needs to be done here. The first is very simple. It's like the binary should always start with the Argo CD hyphen as the prefix name. So for example, if I come back here, if you see Argo CD hyphen demo hyphen plugin, it's actually a valid plugin name, but Argo CD hyphen demo underscore, plugin is also a valid binary name, but Argo CD underscore demo hyphen plugin is not a valid Argo CD plugin name. Why? Because right now you're starting with Argo CD underscore, that's not a valid plugin name. So if you have a binary, something called as Argo CD hyphen demo hyphen plugin, and you put it in the absolute path, this demo plugin is going to become a subcommand of your Argo CD. That's basically the simple use case that I can tell you for now. Second thing is the binary should always have the executable permission, otherwise it is going to get ignored. And the third, it's a condition is that it should reside in your system's path, but in the absolute path, not like a relative path. We'll be discussing that everything in the demo. I think that will make things more clear to us. The next thing, how you're going to name a plugin actually. So as I mentioned first thing, the Argo CD's plugin file name must always start with Argo CD hyphen. So it's basically something like this. So example, if you have Argo CD hyphen demo hyphen plugin hyphen demo, then demo hyphen plugin hyphen demo is going to become the subcommand of Argo CD, and then you can obviously have your binaries, introduce certain subcommands, some sort of flags, whatever you want to. That's basically how you're going to name a plugin. But if you put a plugin's name something like Argo CD underscore and you expect it to work, it's not going to work because Argo CD underscore is actually not a valid binary name that's going to get recognized by Argo CD itself. So for example, if you see, as I'm mentioning about Argo CD-demo plugin, that's how it's going to execute. So if a plugin named Argo CD-demo-plugin, that's a binary name, if it is invoked, if it resides in your absolute path, if it satisfies all the 3 conditions, any user can actually execute this plugin in the form of this way. Argo CD, then the demo plugin, which is like the part after the Argo CD hyphen, it's going to become your subcommand, and then whatever your installed binary is going to have argument flags, it's going to get executed as it is. The problem that we're solving here is that if you were to do the same thing here, you would typically go to the Argo CD's code base, make changes there, and raise some sort of pull request. And Argo CD also has some sort of like other extensions as well, such as autopilot or maybe some sort of lovely plugin that was built. So we want a standardized way that eventually make this available to users without eventually raising a pull request and then going through the feedback loop process again and again. Coming to the question about what are the limitations of plugin, the first limitation, I think the only limitation that we have is right now is that it is currently not possible to create plugins that overwrite existing Argo CD commands. So for example, if you create a plugin, what I mean to say is that if you have a binary installed on your absolute path called as Argo CD-version, so this version, you think that this version is going to become your subcommand of Argo CD. But if you look carefully, Argo CD already has a normal subcommand version. So the normal Argo CD command is always going to take a precedence. It's always going to take a priority over what your binary has if the name conflicts. So if you build a binary, something like of your own, such as Argo CD-version, it's not going to get executed. The normal subcommand is always going to get executed, which is Argo CD version in this case. Due to this limitation, it is also not possible to use plugins to add new subcommand to existing Argo CD commands. So what I mean to say is that you already have some sort of like Argo CD cluster list command, but what if you want to add your own command such as Argo CD cluster upgrade? The problem with this is that your binary is going to have a name, some sort of Argo CD-cluster-upgrade. But what is going to happen is that Argo CD is going to check whether that Argo CD cluster command exists or not. If it exists, that's what the command is going to get executed. So right now, it's not possible to basically introduce your new subcommands that eventually matches with the same name. But when I said that you can obviously introduce your new subcommands, what I mean to say was that you can possibly change your binary name to whatever you want to, and then you can execute it as a normal subcommand. But if you're like, I want to execute as a normal, I want to give it a name similar to what Argo CD subcommand what a normal Argo CD subcommand has, it's not going to get executed. Why? Because the normal Argo CD command is always going to take precedence over your built binary, which we're going to take a look at the demo. Okay, let's come to this one. So we at Qt have actually built this. It's in pre-alpha stage. We have actually built this demo plugin, which we called as MTA, that eventually lets you convert your Flux components to Argo CD. So it eventually lets you migrate from your Flux components to Argo CD CRs. So obviously, I think you can obviously scan there, just go through the repository if you want to. And it's in pre-alpha stage, but we're going to show you a demo exactly of how this plugin mechanism works and how this MTA is going to work for you. Just letting you know that this feature of Argo CD, this hasn't been introduced yet. It's going to be in 3.1. It was actually delayed. We were planning to get it in 3.0, but due to certain reason, we had to postpone it for 3.1. So yeah, I think a lot of discussion. Let's go to the demo time right now, and we'll see a few things here now. Cool. All right. If I go back right now, if you see, I have actually in my absolute path a lot of plugins installed. When I say plugins, I mean the binaries installed. And you see that I have the every single sort of plugin is actually starting with Argo CD hyphen in this case. So all these are the valid plugins. So if I go to the first one, so okay, just wanting to know that I am actually at the master branch of the project, basically on my peer. So if you see some sort of different behavior, that's possibly because of the changes that have been done on the Argo CD's master branch. But yeah, let's go. So when I say dist/argo cd, it's generally the inbuilt binary, the latest binary that we're just building from the master branch, or basically from my plugin branch. So let's get started. So when I said that, the first thing that we're going to do here is we're just trying to execute a simple binary called as dist/argo cd, and you obviously see that it's going to execute very simply. There's nothing different, obviously. Let's go to this one. Let's see what is it about. So if I go here, you see that I have built this binary called as the argo cd -cluster-list. If I try to execute it, it eventually should first print this line fetching the list of clusters. Then it should execute this command, and then some sort of behavior, whatever it wants to. So that's my custom binary that I have built right now. But do you think it's going to get executed if I simply try to? Obviously no, because how is this plugin going to execute it is this way. So everything after your some sort of cluster list, it's actually going to become your subcommands. If I go here, let me. So okay. Anyways, if you see right now, what is happening right now is this plugin binary is actually getting executed. So if you see the fetching the list of clusters connected to Argo CD, that's what is happening right now. Initially, what we planned to do was when this feature was eventually rolled out, not rolled out, but when we were trying to discuss, we thought that instead of using this prefix like a hyphen sort of thing, we can execute the commands as it is. So that is the reason I thought it would not execute. But when you try to execute like this way, cluster-list, it's obviously going to get executed because there's no subcommand called as cluster-list in Argo CD. But if I try to probably, some sort of say that I'm going to create a binary called as this one, and I'm going to just do some sort of thing here. And I'm going to version.sh to just let me see. Okay. As you can see, I have this Argo CD -version installed. Oh yeah, you see that Argo CD -version is installed, but it's not going to get executed. The reason is very simple because if I say this, you see the plugin, the binary doesn't get executed. Why? Because this version is a normal subcommand. But let's get started now. And if I go to the MTA one, so this is my generally the this is basically the MTA subcommand that we generally have as a binary installed. So all these have its couple of subcommands, the customization and Helm release. And eventually we're just trying to, first of all, apply some manifest here. If I simply say Argo CD MTA scan. So all this is basically coming from your binary. All these subcommands are coming from your binary. You see that I have basically two customization resources. That is a pod info and my customization that is present in the default namespace. I have a couple of Helm release and basically in the default namespace as well. So the first question that I'm basically going to do right now is just convert this customization into the Argo CD compatible Argo CD CR right now. So right now we're talking about the customization. So you're going to pass the name of the customization. Let's say it's the pod info, and we're going to do that. And then the namespace is default. If you see right now, it's actually generated me some sort of an application set that is eventually matching how your the customization is going to look like. So if you want to take a look at how that looked like, I think this is the manifest. That was basically my simple manifest, what I just converted into an Argo CD CR right now. And if I go to the, let me just, right now, you can see that I also have another one, which is the customization. That is the pod info, which is present in the default namespace. So if I do the MTA scan again, I can see that this is present here, which is the pod info in the default namespace. If I simply try to convert this to my customization name is the pod info and the namespace is default, you can see obviously it's going to get converted here. That's going to get converted in the application set. If I do the similar thing for the Helm release, it's going to get converted to my application actually, not the application set. Basically, we're going to convert to application set for your customization, but for your Helm releases, we're going to convert to an application CR. That's something, because it's in pre-alpha stage, we're working currently on that, but that's something. So if I try to do this, I mean, there was Helm release. Okay, I can simply do that. And you can see that if I go here, there was a Helm release that was present in the default namespace with the Helm release names, with the Helm release name that eventually got converted into this application. If you want to take a look at this one, I can show you how the manifest for this looked like. This was basically the manifest. It's like a simple Helm repository. And then you had this Helm release that was present here. And it's eventually referring a Helm repository in the pod info, basically. Yeah. And then we also had another Helm release, which was basically the pod info. If we want to convert the same to an Argo CD manifest, let me pod info and the namespace is default. Then it got converted here. So that's basically about your MTA. But the main, since it's in pre-alpha stage right now, I just want to let you know that I think right now, if anyone wants to play with it, I think one of the things that people might get excited about right now is we are introducing the plugin rather than MTA right now. MTA is just an example what we're telling about. But in simple terms, I think the plugin interface that we're introducing in 3.1, it's going to solve a lot of problems. But few suggestions that we would also need from the community is related to how would you want to handle your sort of flags behavior. Because right now what we are is, as a user, do you want to have your binaries work with normal Argo CD global flags? For example, you have a global flag, something like server, but would you want your binary to respect that flag, or would you want your binary to replace that existing value or not? That's something we are actually discussing about the community and with the community. And this is one of the reasons why this feature actually got delayed to 3.1, because we are still working on whether we should do that or not. But yeah, I mean, eventually that's it. Just concluding the things here, again, very simple. If I come back the slides here, these are the only three conditions. The binary should start with Argo CD hyphen. It should have the executable permissions and should always reside in the absolute paths. So, and yeah, if you have any plugins, some sort of Argo CD hyphen dash 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 dash, this dash 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 is going to become your normal subcommand, and then obviously going to get some binaries in, your flags, whatever you want to. So yeah, I mean, that's it. I'm going to present a similar talk tomorrow at ArgoCon with much more detail. I know we had few time here, but I think if you want to just go through this talk again, I think a lot of people would be interested tomorrow at ArgoCon at Lightning Talk. So if you want to attend that, let me know, and I think we probably can discuss that. Any questions right now if you have for this one? Okay, I think looks like no. So yeah, I mean, thank you everyone for attending this talk, and looking forward to meeting you all at Rejekts now.
Thank you very much. I'm surprised that you could make it in time, even after you had the technical issues for the half of the time. So right now we will have a break, and the next talk is going to start at 10:55.
Thank you. So hopefully by the end of this talk, you will know why you haven't seen this combination before, okay? But first, let me just jump in to tell a few words about me. So again, my name is Peter. I'm from Hungary. I have a PhD in computer science, and I did actually work in the field of networking. So I have an unusually deep knowledge about networks, how they work. And I'm also a part-time assistant professor at the other university in Budapest called Eötvös Loránd University. But in the meantime, we also founded a company who created this tool called Stunner. And in the end, I will let you know what Stunner is, but it's basically a way to do WebRTC in Kubernetes. And I've been working with various cloud native technologies for like 7 or 8 years now. So let's jump in. Like what WebRTC? Does anyone used WebRTC before, or Okay. Oh wow, that's great. Cool. And by the way, I think everyone is using WebRTC all the time, right? Because that's just the protocol behind all these meeting tools like Teams, Meet, and Zoom. So all is using WebRTC because it's the way, the name is actually, like web real-time communication. So it is how you do real-time audio and video with your browser, or any mobile app basically uses WebRTC these days. It's been invented by Google around, like 2010-ish. But now it's an actual IETF standard, so everyone is interoperable and stuff. And it's built into all browsers, not just Chrome and the Chrome copies, but like Firefox has the implementation and Safari as well. So because of its standardized and very easy to use, so we always joke about this, that you can make a video call with like 3 lines of JavaScript in your browser. That's why people starting to use it. And not just, like regular meetings. There are other like, audio video use cases that uses WebRTC. So like if you call a call centers, although, like the first part is a classic voice over IP call, but usually your operator picks up in a browser, and then, that part is WebRTC. There are specialized apps for like, EdTech or telehealth and so on. But, since I think a few years now, there's a lot of other use cases emerging. So like, remote rendering is a thing. So like rendering 3D objects and then stream down with WebRTC to your browser. We see a couple of weird use cases for like high frequency trading to, like stream arbitrary data with WebRTC because it's, was designed for this kind of real-time use cases. And now, voice AI is a thing. So, OpenAI has a WebRTC interface that you can use to connect to like a GPT or Omni model, and then like just talk to it. And now they use WebRTC. Before that, it was WebSocket, and that was just a failure. So, because how hard is to do real-time communication. So why is it that WebRTC is not easy in Kubernetes? So first, WebRTC is just like anything else. There's a quite large open source ecosystem around it. There are like so-called turnkey solutions, like media servers. You can like, basically it's almost like a Google Meet copy. You can just deploy it and then use the API, and that's it. There are also neat frameworks, mostly in like this Pion is in Go, very, very popular. The other one, Media Soup, is in JavaScript. You can just, start building your own custom solution. And then obviously you can just grab them and put it into a Docker container. But if you're in the WebRTC world, you can find these blogs. So this is bloggeek.me, one of the most popular blogs in the WebRTC world. Just, a recent blog post that, like how do you start with WebRTC? And then one of the section has this title, Don't Use Docker. And so they don't like it. And the reason that they don't like it is, how WebRTC was designed and how the networking part of WebRTC is designed. So, it's always about networking, storage, or security that you have troubles. This time it's networking. Because the networking in WebRTC is fundamentally peer-to-peer. So you will always talk to one peer, and then your peer will talk you back directly. So that's a very weird case. And if you call your colleague on Microsoft Teams, you will actually see that you're directly talking to your colleague's IP and then back. So it's pretty interesting that it was, again, designed for peer-to-peer. Now, obviously, if you jump into a group call, talking to peer-to-peer for any other user in this WebRTC session is unfeasible, not just because it's the full mesh looks insane and there's other problems with it. So anytime you have like a group call with actually at least 3 person in it. You will go through a so-called media server. So that's one of the key elements in a WebRTC architecture. So like you will always send your audio and video to the media server and grab any other, participant audio and video from the media server. So it's a more scalable solution. There's actually multiple ways to do this. The old way was called the MCU. It just means that, that server will mix up the video and the audio for everyone, and then you just download one common video. But the more like popular ones are actually using this SFU model, which is just a dump forwarder. So like they collect everyone's. The media server do not touch, these streams. They just like forward it and multiplex these streams. So that's just a thing. But still, the important point is that the protocol is the same. So no matter if you as a user from your Chrome talk to someone else's Chrome or a media server, the protocol is the same. So how a call is built up between a user and a media server is the same if you were calling another user. So that's why I'm going to focus on this use case as well. And this is why it's actually very weird. So this is how a call is built up. You as a user and the media server on the other side will choose a random UDP port. And I hope you get the feeling that communicating via a random UDP port is not really cloud native, and that's going to cause all the problems out there. And you can't really influence this behavior. I mean, you can just like shrink down this port range that you will choose these ports, but it's fundamentally random. And then there is no session information in a WebRTC like protocol on it. You will directly correlate a stream to a user, to your peer, based on these port numbers, and then that's it. Now, but how can you connect to a random UDP port? There's another element in a WebRTC architecture called the signaling server. Basically, you upload this information in this format called SDP, which is a very ugly text-based descriptor that contains a lot of information about how you want to handle this call. And then one of the information is this random port number. Okay, so there are other things like codecs you want to use and encryption keys, because it's actually peer-to-peer encrypted with DTLS. DTLS is just TLS over UDP. So, but one of the key information is, okay, I opened this port for you, basically. So you upload this, and then your peer downloads this port information in this SDP, and then you just try to connect, okay? I'm going to try to connect this random IP and port. And then I trust that you can see this, that this will, no way this works unless you are both on the public internet, right? And then, a media server can be on the public internet. And frankly, most of the WebRTC architectures that are out there now, it's on directly on the public internet, because otherwise this is going to be very, very complicated. But you as a user, you're never on the public internet. So we need to solve this problem. And that's where some funky protocols come into the place, which been out there for many, many years, but I don't know if you ever heard about it. At least I was not hearing about this until I joined my colleague in this company. And the first one is stun protocol. So again, the problem is that this is a more usual scenario. So you working from home, you're behind a home router, you have a private IP, and then the media server sits on a cloud provider behind some sort of like cloud net, but it's also on a VPC, so it has a private IP. So like one thing you can do with this stun protocol, it's very, very interesting, is that you can send it's one packet query, like tell me my public IP and the port you can see me, and it will just answer, okay, your public IP is this, and the port, usually, there is net between, so it will be a different port, but this is the port that I see this. So this is very, very similar if you go to like type in whatismyip.com, it's just instead of your public IP, you get your port number as well. But not just that, that's a very crazy thing, that, because this is a standardized protocol for 20 years, you can have these net devices or routers, whatever, to leave that port open. And so you will actually also upload this information. We call this the server reflexive candidate. That's the WebRTC term, but it's not important. So this public port and IP And then your peer can try to connect to this port as well. So the public IP and the public port. And then if your router is set up in the correct way, or actually it's the default settings on any residential router, it will actually forward this traffic to you. So it's pretty crazy. I've never heard about this, and then you can do this. Stun is used outside of WebRTC, so again, it's not tied to WebRTC. So if you use any like peer-to-peer VPN, WireGuard-based stuff, which is very popular these days, like Tailscale does the same. So this is how Tailscale can actually connect peer-to-peer with stun protocol. So this is very cool. And it's actually usually works. Again, if you're doing home office and call your colleagues on Teams, this is how you can actually hook up your traffic peer-to-peer. And it's also mostly working on cloud in simple setups as well. But the problem is that I trust that if you have heard about security a lot, that if you're on an enterprise network, no way this is allowed. Yeah. So on the user side, and if you dig up even more your media server into a Kubernetes, it usually does not work as well. I will tell a little bit more about this on a later side. So that's a huge problem. Is this stun? Although again, many times it can work. In many cases, just flat out blocked due to security reasons. So what can we do then? There's another funky protocol called Turn, and Turn is basically a relay server that you can send all of the traffic through, and then you try to circumvent these net devices. So again, if I go back, Stun it does not send your, so it does not flow through traffic. It's just one query, what is my IP import, and one answer. But the audio and video goes peer-to-peer as well. Turn, you will send your audio and video through the Turn server. So that's how you circumvent these devices. It's really working essentially quite same as if you use SSH tunneling. So it's like a tunneling protocol, but it's just overly complicated because it's it's an IATF standard. So there's a lot of stuff you can do. But basically, you can use in two modes. You open a Turn tunnel to the Turn server, and then you will ask the Turn server to forward your traffic to a given IP import. So you can ask the Turn server, okay, I know the IP import that I want to connect to my media server. That's the random stuff. And if the Turn server can reach it, you're good to go. So that's, again, almost as the same as SSH tunneling. And just as SSH, you have a reverse tunnel mode. So I can ask the Turn server to open a port on the Turn server, and the Turn server itself can be on the public internet. And again, most of the public Turn servers are on the public internet. And then my peer can try to join, connect to this public IP import. And then the Turn server will just reverse tunnel back to this to my IP import. So this is how you can circumvent these net devices. And in most of the cases you can do this, also open a tunnel and then connect to the reverse tunnel as well. So this is how you circumvent all the net devices on the that you're behind. So that's pretty cool because. And again, you can send all this information in this SDP as well, so your peer can try this. And so the cool thing is that this will almost always work. So again, and it's just like SSH, it's tied to one port as well. So it's actually tied to one port per protocol because you can use Turn over UDP, over TCP, or over TLS and DTLS. So the port is your choice. And the way usually people use it is that they open it on TLS 443 so that the firewall thinks that it's HTTPS. So they will let it through, unless you have something very, very restrictive environment. So that's cool. The problem is that now you flow all the traffic through the Turn server, so that can add latency. And then obviously, if you use TLS 443, tunneling a fundamentally real-time UDP traffic in a TCP tunnel, not the best idea, but then again, it is better that you actually have connection, and sometimes the connection is bad rather than not having a connection. So the key thing here is that even in current WebRTC deployments, because users can be behind a restrictive firewall, about like 10-20% of every WebRTC follow, let's say, uses a turn server due to a restrictive firewall. So no matter what you do in your WebRTC deployment, you will need a turn server to solve this problem. And then let's jump to the, and then all this process where you like, open the port and then gather these candidates, your like normal open ports and this ton reflexive candidate and this like open a reverse tunnel return, and then try all these connections. It's called ICE. It's just, if you hear this term, this is the ICE process, how you like collecting this IP port pairs and then send it over and then try to connect to your peer. So jumping on the other side, like Kubernetes, I will just jog this through. So, how a Kubernetes cluster usually works is that you have nodes, worker nodes. They have a private IP most of the time. They may or may not have a public IP, depending on whether you use a public or a private cluster. Pods have their own virtual, IP subnet. Usually like having a /24 subnet per node, and then we use services. Cluster IPs, have their own public virtual IP, private virtual IP space, and then you can have a load balancer type service where you get a load balancer with a public IP from your cloud provider, and then a user can try to join this pod, okay? And then the problem here is that you will go through so many layers of net, you will not be able to solve this kind of like, how can I connect to a random UDP port in a pod? This is just like, you can try to build something, but I don't think it will work. And then the other problem is that usually because you go through so many layers of net, you can try this stun protocol, and then very surprisingly, sometimes stun goes through, but most of the cases it will be blocked by one of the layers. And it's just dependent on, the CNI, your queue proxy mode, your load balancer provider. So many things, it just depends on, usually you can rely on. So what can you do in Kubernetes? So the first thing you can do, and that's most of the people we met in the WebRTC world are doing, if they use Kubernetes, is just run these media servers in host networking mode. So, in host networking, rather than a pod having an IP from this like pod's virtual network, they bind their networking to the worker node. And if that's a public cluster, and usually they will use a public cluster for it, they can advertise the address of the node itself, the public IP, and that way, and then you just allow this random UDP ports, like this huge UDP port range in your firewall, you can connect via this public IP and the random port. So again, this is how most of the deployment works, I believe, for those companies who use Kubernetes. But if you use Kubernetes enough, you know that, you shouldn't really use host networking. It introduces so many problems. So like, you're going to have a hard time to just upgrade these pods because they can't run on the same node at the same time due to port conflicts. And, in case of WebRTC, because, sessions are very long, you're going to have like, maybe you want to leave those pods running for hours after termination, just to, like not terminate the current session on them. When you have a lot of load and you want to scale out, it's really, really hard because you want to scale out nodes first and then pods. It's just really slow and also very cumbersome to do. And then it's just a security nightmare. So again, because of how host networking and network security policies work in Kubernetes, it's just people really don't like this so much that in most enterprises you just can't do. There is a policy that will block you if you want to run a pod in host networking. So and then again, at the end of the day, you will also need a turn server. When the user is behind the firewall. So that's it. If you want to use a normal pod in Kubernetes for your media server, you want to have to use a turn server as well. And then just basically send the traffic through this turn server and circumvent this, like many layers of net. And so the good thing is that there are a lot of like providers, so you can buy it as a service from big companies like Cloudflare or Twilio, and there are a few other small providers. It's very easy to set up because it's essentially just a config with an IP or host name and some credentials. So you can add this to your configuration and you're good to go. The problem is, because Turn is a relay, you will send all the traffic through the Turn servers. It can introduce a lot of latency, which is, again, because it's real-time communication, sometimes it's bad. And then, if you have a WebRTC stuff, most of the cases it's video. Video generates a lot of traffic, and you're going to pay by gigabytes, and you're going to pay a lot by the gigabytes. Why? Because I think Twilio also uses AWS, and then the network cost in AWS is by itself a lot. So you're going to have to be very careful. But it's actually a good idea to start with this because Turn is a standardized protocol, so you can just always switch this in your config. So the next thing is, obviously, there are a couple of open source Turn servers out there on GitHub. Most of the cases, this tool called CoTurn is one of the most famous one to use. So you can just actually start your own Turn servers. You can put them in the same region as your like Kubernetes cluster is running, so that you don't have too much latency. And then you can do this. The problem is it is like really hard to do because you're going to have to take a lot of care about these Turn servers, because essentially you like relaying all the traffic now, because how further you dig these media servers in Kubernetes. So most of the traffic will go through these Turn servers. If they go down, all your connections will go down. It's never a good idea. So building a highly scalable Turn server, architecture is really, really hard. And then you're going to have to deal with like, geo distribution, because if two like Australian people wanna have a call, you never want to relay them through whatever US West, right? So that's actually a very hard problem. So, but then this is what Kubernetes is for. Isn't Kubernetes for like running these things like globally, multi-cluster, failover and stuff? Yes. So you can actually grab the Turn server and put it as a regular pod, open open them to the world with the load balancer. Again, Turn have fixed ports, so you can do that. And then if they are on a regular pod network, they can just reach the media servers on the regular Kubernetes network. So that is the way to go. Although, if you just grab any random Turn server and put it like this, you will need a couple of toolings so that it's just high available and secure enough. And then this is why we built Stunner. So Stunner is basically a Turn server, although it's funny because the name is Stunner. We do speak the stun because it's essentially part of the same protocol stack. But the magic happens in Turn. You can open these Turn tunnels and then publish them via any cloud load balancer, and it's purposefully built for Kubernetes. So all the tooling is around it. It's written in Go. It's based on this library I mentioned called Pion, and then you can configure it, via just any other regular Kubernetes resource. This other stuff that with the dotted arrow means that still your media server has to connect to the user, and again, most of the time it can connect directly back to the user using Stun. But if not, the user can open a reverse tunnel on Stunner, and then the media server can connect back. So, and then the great thing about it is, it's very easy to config, install, manage, because it's Kubernetes, and again, we purposefully build it for this. You can just use horizontal scalability. You can also use multi-cluster. As long as you have pod connectivity, it's okay to open a Turn connection in one cluster, and then if that cluster you can reach the other media servers, it will just work. One drawback is that this Turn tunneling stuff costs a lot of CPU, so you're going to have some CPU load on this, but again, you can just start to horizontally scale Stunner, and that's it. So, and if you see this, it's essentially the same analogy that we use for like ingress and an HTTP server. So we never really expose any HTTP-based web servers in our cluster. We use an ingress to do that. Why? Because it's just easier to manage. It's more scalable and so on. So much that now used Ingress a lot. It has its own limitation that they introduced the Gateway API, which is just, you can call it as a next generation Ingress, the gateway. And we implemented Stunner so that it uses the Gateway API. So we are actually a quote-unquote official Gateway API implementors. We are listed on the Gateway API side. So that's cool, because how this works, we really try to mimic the behavior how the folks build Envoy Gateway. That we have actually a Stunner operator. You can just install it, it's one Helm. And then you can create, like a couple of configuration that we have CRDs for. I'm not going to go through all this. It's just, it's Kubernetes, so a couple YAML files you have to just start. You create a gateway class that's, very similar to Ingress class. And then you create a gateway. That's when you specify the ports, that which one you want to listen. And in our case, you have to, state that whether it's turn UDP or turn TCP or turn TLS, or actually turn DTLS we also support, but nobody uses that, to be honest. But anyway, and then, if it's TLS, just attach a secret. That's it. And that will create the actual deployment of like Stunner, or as we call Stunner D, the actual daemon, the turn proxy daemon, and then create the load balancer services as well. You can have a lot of room to configure it. You don't actually have to use the load balancer. Some people use node ports because, actually load balancing with UDP is also a nightmare. So sometimes you can get into troubles of, how your cloud load balancer is handling UDP. So, and the final thing is that, because turn is essentially a tunnel, so if you can connect to a turn server, essentially you can send traffic to everywhere where that turn server can reach, which is also a huge security risk, right? So you want to be careful with that. In Stunner, we designed this that Stunner actually blocks every traffic by default. And then you have to explicitly allow those endpoints that you can send your traffic to, which is normally is just your media servers. So like you have to point this to your media server service, and that's it. And when you do that, users can actually connect there. So that's why we use UDP route, and that's the final thing. So again, with a couple of YAML files, I can tell this. I can start a Google Meet copy that like highly available, works really good in like 2 minutes in any Kubernetes now. So that's why it's good idea to use Stunner. So that's all. So again, this is why we created Stunner. I think we started this like 3 years ago. Many, I think, big companies using this right now, hooking through a lot of traffic through them. And then again, this is just comes down to how WebRTC was designed with this very weird peer-to-peer connection setup with random UDP ports that you cannot really use in Kubernetes. But this turn protocol is a good way to build like this kind of like gateway service. And that's what Stunner can do. So that's all. And hopefully we have sometimes for a few questions.
I would have one.
Yeah.
So I didn't get completely how you solved this problem with the random ports and the case that my nodes don't have a public IP, so the host networking is also not an option.
Yeah.
So, and then I have a load balancer IP, and usually I have to tell like what port I want to use for that. So how do you do that?
Yeah. Again, so that's kind of like behind with this whole like signaling plane. So by the time the user opens this turn tunnel to Stunner via just a standard load balancer, again, that works. It knows because of the signaling plane, which is out of band, so usually uses HTTP with other servers and stuff. So it knows where to connect. So basically, it knows the pod IP and the random port of the media server that it opened. So it can ask a Stunner specifically to connect this pod IP and this random port.
Yeah, but does this random port has to be open all the time already?
No. The media server will open this just for that user. And then the way how the Kubernetes network works is actually it's not blocked by default. Or you have to allow it with your security policy. But by default, you can connect between IP. You have all connections. So no matter what port is open, Stunner on the same pod network can reach that random port of the media server.
The load balancer has to support this feature, right?
No, because the turn tunnel is a fixed port. So you're tunneling, on a fixed port to Stunner, and then it will just like decapsulate that tunnel for your traffic and then send it through the Kubernetes network. I know it's pretty confusing, so it took me like 2 years to understand this, because it's just really, really cumbersome how all this protocol works, but it does work. And then, this is the point. So other questions? Yeah?
It's just a short question. The start protocol, does it use UPnP then for the that traversal for clients? Or?
I don't think it uses, just for the fact that I have no idea what UPnP is. So.
I thought that's the feature on the routers which opens automatically.
Oh, maybe it is, but I've never heard that term. So maybe that's under the hood. So I don't really know how they leave that port open, but they will leave that port open. So other questions maybe?
And it should be the last one also, because we are running out of time.
Yeah. Yeah, you can use. However, there is one caveat for this. So in many cases, you have so many layers of NAT that you will lose the user's public IP. So you have to set up the load balancer so that it is not do source NAT. And in many cases, you can do that, but you have to be very specific on your load balancer configuration to not do that. But yes, you can do.
Okay, so thank you for the talk. It was very interesting. And in less than 5 minutes, we will have the next talk. So, gonna be prepared. Is about the Gen AI CLI clients, and we're sold by Artyom. So we prepared, and welcome to the stage.
Thank you. Oh, okay, you can hear me. It's like the screen sharing test. Can you see my screen? Hey, together. Thank you for joining our talk. It's going about making Gen
AI, CLI agents works for you DevOps day-to-day operation. Sounds really complex, but it's very easy. And we are going, but first to my person, who am I? I'm Artem Laiko, a platform engineer working for IITS, certified KubeCon ambassador for platform engineering, and published book author of implementing GitOps with Kubernetes. And I'm working for IITS. We are starting 2019 as a software development company. Then we adopted platform engineering, cloud ops, and we're doing the real AI engineering stuff. So we have engineers with PhDs, now about 6 or 7, and they're doing AI longer than the companies exist. And yeah, now we are about 160 employees, and last year we have about 3,000 applications, and just 1 person was hired. So too much. Now we are getting through the target or to our agenda. As you can see, we are going to find first some terms, then why we are using private LLM, then what we define by smart command line interface, showing you some real use cases. We try to create proof of value, not proof of concepts. And then we are using for code gen, investigate, and self-healing infrastructure, and share also our learnings with you. And let's start. Some terms to the beginning. I think the most of you are tired of the blockchain engineer, metaverse engineer are now changing 2 years ago and are now AI engineers. And hopefully, if not, I mean, you are here, so you are not tired of the topic. Thanks for that. And this is also was our motivation to show how you can really use Gen AI and another stuff in your daily work, not just the fancy stuff. And Gen AI are not just only chatbots. We also created, for example, Tender for our customer. We are working for the Open Telecom Cloud and the systems. And if they need a tender, customer uploads the documents. You don't need to have an interaction with a chatbot. You will getting all the stuff you needed based on that, building a contract. So not just chatbots. If we are speaking about agents, we are not speaking about the MCP and all the other stuff. We are speaking the light way, an agent getting instruction, getting access to your tools, and you can give him some advices based on GPT script. I'm going to show you. And why we're using private LLM, or what is private LLM, is just LLM models based with, enhanced with, for example, we are using it with RAG, or we are using it with our documents collection and put in it. This is how we defined private LLM. Yeah, and then we have retrieval augmented generation called RAG. Short term is just put to your model some data and gives them some intelligence. Okay, then we have smart CLI. Yeah, then we're getting the smart CLI term, and also AI engineers for us are not prompt engineers, blockchain engineers. They're really the Python data science engineers. That's how we understand them, or platform engineers that are using AI on the daily basis. So yeah, let's go into the smart CLI definition. Our definition is assist you in filtering out key information and enhancing it with AI for your DevOps-related task or platform engineering, however you want to call it today. And which tools do we use for our daily work? We're using Holmes GPT. It's an AI assistant that investigates incidents like humans does. You're getting better results with Holmes GPT, but it's harder as the entry point is much harder, because if you need to customize it for yourself, you need to know Python. Because of that, we're also using GPT script. It's an agent-based approach. You can define by human language what do you want. The entry is very easy. But if you have different agents combined with each other, it's a little bit complex and the hallucination is very high. And here you can see what I mean by easy entry. This is a snippet from a CLI agent. For GPT script, you can just say use, for example, I allow you to use tools on my device or on my Kubernetes cluster. You can put in description, you can pass through some args, you can disable or enable chat, then it's going to be ping pong until you say I'm done. And then you need a prompt or instruction to say, hey, you are, I don't know, you have just 3 tries to making things work, or you are a DevOps agent, or you are alert agent, and giving them some instructions how you're doing if you are prompting. Yes. Private chatbot, we mean by private chatbot, for example, we add domain knowledge, or why we're using private chatbot, that is ChatGPT not unaware of it. Also confidential docs, we have a lot of customer critical infrastructure provider, high regulated, you can't just put documentation to ChatGPT. And another one, so we try to combine both worlds. and also using private models, enrich them with RAG, or using RAG for that. Yeah, you get faster access to confidential information. And to give you an example, for example, how we build it, or that you can get just a little bit more clearance. We are using, for example, our solution, HomePort AI, and we combine it with LLMs. We are using public LLMs if the user need it, so they can use OpenAI, Gemini, all the stuff. We just forwarded the token and count for them and have some middleware on top. And then we have hybrid LLMs because we are working with the systems. They provided a LLM hub. We have customers that are using, for example, voice over IP or text to voice and another stuff based on all the things. And if you need specific models, we integrated them. And then we have, of course, our private LLM hubs where we just load models like Llama, Gran, Mistral, and combine them with RAG. And we combine it with RAG. This is the upper side. We're using Airbyte. Airbyte provides you about 550 connectors right now, so you can put Jira tasks, Kubernetes logs, everything you need, and enrich or combine it with your LLMs on top. Of course, they must be compatible to RAG, and our middleware just not only creating all the stuff, it's also seeing or improve, validate your prompts. So you just need and load the data they are needed at the time, and we built it multi-tenancy from the UI. We created workspaces, and the workspaces you can upload your collection, and over the collection you can also then chat with your specific data, and it's isolated. So FinOps or HR don't getting access to the sysadmins, as a sysadmin can't access the data. So we try to establish the multi-tenancy from the UI based to Kubernetes and also to the vector databases. It was a hard path, but I'm not speaking about today our solution. It's just that you're getting the view and see what we are using RAG token and how we extract it and how we combine it to use it with our solution or for our daily task. And it's gonna be the magic coin. We are using it for investigate, for code generation with continue dev. Of course, we are aware of v0, bold, new, cursor, but how I say it, we try to create proof of value and not just showing you some use cases. And also we are using it for self-healing infrastructure with GPT script and pipelines, MCP, are going to be at the moment under research and development we experience. So I can share much on that. I can just share the ideas. And these are, again, other use cases. I will provide everything you see in the next slides or in the demos. You can download it, you can go through it, you can also see the videos, so you don't need to take photos. Also, I provide a slide at the end with all QR codes you can going through. These are the use cases we are using it, and let's take a look. Gencode is going to be the first use case. We are using continue dev with IntelliJ or VS Code and extracting RAG token for that. Why we are doing it? For example, if you are trying to bootstrap, if you are a junior developer or platform engineer and try to bootstrap a new cloud container engine with all the stuff you needed, it's a managed Kubernetes solution from OTC, and you ask ChatGPT or another solution, how I bootstrap it with the Terraform models they provided, you are getting a very deprecated solution, also with internet search and all the stuff. And if our junior developer started with that, they show us the solution and they say that doesn't work, and we ask them, this version looks very old. They say, no, it's a new one. We asked ChatGPT and also provided it with deep search. And then we say, yeah, but it's not the real one. Go to the docu, search for it. I don't know why it's happening, because ChatGPT have access to also to the documentation, but it's still creating, not also, they have missing values inside. And if you, for example, combine Llama, an older model, and gives them some RAG or combine it with the documentation over the Airbyte, we sync it every 30 seconds, scraps the documentation, no magic. It's also just not provide you the right values and set it for you. This is in view from IntelliJ Insights. You can say, generate my code, I need to bootstrap this cluster, and it's gonna bootstrap it for you. It also gives you advices. So you, for example, you need to keep in mind that the folder that you have to enable this one or this one, because then it's going to be work. And it's helped a lot. This is how we are using for the generation part. now it's generated. If you try to apply it, okay, let's say we have created our infrastructure, provision it, and the next step will gonna be something like, okay, now the cluster is running, how we debug it, or if something is happening or something is not happening, how I can ask my cluster if it's healthy or not. For this part, we are using our developer, or we are using GPT script and Homes GPT. Most time, Homes GPT for investigate. They are also they are robusta is the maker behind it. If you want to ask him more or see more use cases, just visit them. You can see the stand number here. And we are using for GPT script and Homes GPT, OpenAI or HomePod AI as a backend. Very easy. Let's take a look how it's going to be look like on the CLI. For example, we are going to deploy just some broken stuff, and we are, as you can see in the human language, ask once with Homes and say, does my cluster have some issues? And we also say fix it. It's just to show you that Homes GPT don't fix it. And also we repeat the question with GPT script based on the CLI. Here you can see hopefully a little demo. It's gonna be, now we are going apply some broken stuff, some image errors, some really stuff you can find it very fast, but it's just for the demo purpose. It's also, then we say, for example here, Homes ask, does my cluster have some issues? They built it very well, so they try, I think it's not seeing a come on. And then you can see, it shows you, for example, you have an invalid image tag, the repository doesn't exist. This is a really simple example, but it also works with complicated. For example, if you're not a database expert, and I waste a lot of time to seeing if PG Postgres database change, I waste a lot of time to finding this UUID flag, I need to say it in a new version, and if you combine it with that, it's found in 3 minutes, and I need it 4 hours. Maybe I'm not a PG expert, but I think a lot of people also, if a junior started, takes a look. This is how we are using it for the smart CLI. Also with a little bit fix. In the next part, the GPT script also fix it. It's not just investigate, it's also searching for a solution and fix it, paged it, and if it's done, you can see the token window increase. This is also a reason we're using private LLM, because if the bill going high and the developer making, and now as you can see, everything is fixed. If you say pods, it's running. This is from the CLI perspective, but we are engineers, so of course, let's do it at the Kubernetes native way. This is a little bit more complex infrastructure, but still simple. Here we define, for example, multiple agents. The request handler, this is just an agent. We give them some instruction, for example, like you are working with human. You say, if I have a FinOps question, go to another agent. For example, if I have a Kubernetes action, so they just forwarded the request to the right agents. Then we have a Kubernetes agent that have more instruction how to debug and which tools to use. And of course, we are getting here an issue for deployment. And we have a shared context. You can define a general context for all your agents to tell them, for example, don't waste too much tokens, or just, don't know, your output should be 500 chars long. So, because if you, for example, have chat enabled or another stuff, yeah, your bill increase, trust me, it's growing very fast. And also we are using then, we deploy it as a job, for the example, and it's have GPT interaction, or GPT script interaction with our own backend and with Reg. And yeah, it's gonna be scrap website and docs and everything like this, deployed on Kubernetes. And like I said, we are creating here an ingress issue, which is not an issue from point of Kubernetes. Everything working well, but our compliance say you need to use a specific ingress class to get the IP address and all the other stuff. So if you're asking GPT script, or if you're asking Homes, is my cluster, something wrong with my cluster? You will see, no, because point of Kubernetes, it's not wrong, but in point of company, it's wrong, and we are going to see here again a small demo. We are applying, for example, a job with GPT script inside, like in the architecture, and then we are going to check the logs and seeing if they fix it without the reg token, and then we apply the similar job, but we just change the token and see how it's changed. So for example, as you can see here, we are going first apply the normal deployment. Come on, it's going to be job created. The token is lying in the secrets. It's, like I said, I share everything, then we can see the logs. And as you can see, everything is fine. Healthy, nodes are running, pods are running, everything is fine. Okay, now we are getting, and let's see if the ingress is coming up. You can see no address, because our compliance policy say you need a specific ingress class to do it. And then we deploy now the same, everything is the same. We're just changing the token and see what's happening now. You can see the model is working, or it's playing with the backend a little bit. I'm in time. And then you can also see that they started to fix it. They found the issue, and then they started to patch it. They also refactor it, they configure it, and then also now you can see it shows you now it's compliance with your company policies and all the other stuff, and I patched it for you. It works for you. Now it's very dangerous to do things like this. I mean, come on. Giving GenAI with non-predictable access to your cluster, to your backend and all the stuff, it's a little bit crazy. And what we are doing the next, we are engineers, so we like to over-engineer all the stuff, and we say, hey, let's put GitOps on it, and let's put another stuff on it. Here you can see also an abstracted architecture, but the main points are, now we have a DevOps bot with more instruction, and we have multiple comments lines. So we give them an instruction, curl first this one, like a senior will do, this one. So we're giving in order how to work out, and then we also enable him to looking into the alerts from Prometheus and also collect the alerts, and then we say, okay, if you now find an issue, what you're gonna do next? We don't want to fix it in the cluster. We say we're giving him access to a GitHub repository where all the code is lying, and then check it if you find a solution. Also create a pull request. We approve it, and Argo CD gonna deploy it. In the most cases, this case is going, I don't know, failed about 30%. So because you can execute it 20 times, and yeah, it's GenAI. Yeah, manual approve it. Yeah, manual approve it on the dev. You can auto approve it. But we also said not just only create a pull request, also send a notification to Slack and say the user, something is wrong, I create a pull request for you, so they are aware of it. This is how it's gonna be looks like. Here's the whole video, how we set it up, how we configure it, and all the stuff. Like I said, at the end you also provided it, but here's just the short outcard, how it looks like. You're getting in Slack a message, it's told you we have a problem with our load balancer. For example, if you're using OTC and you want to expose a service, I don't know why they built it, but it's built because I think it's an open stack under the hood, and you need to set a specific ID to getting IP address. And so you need access to the doc, so you need to understand it, and the agent understands it, and also, as you can see, it's a diff in IntelliJ. First, you don't have set the load balancer ID, and then you set it and get the IP address. You get also the instruction how to do it, or it helps you if you don't know where to start. And this is the most use cases. We are also responsible for the customer success support for OTC, and I think about the last 2 years, 90% of the requests asking how we can set this. We say, search in the docu, we have documented it 3 times, and again, and I mean, last year before we holding a presentation like this one, we getting this request, and we also show them, because one day we getting approved and show, they say, and you have a lot of requests like this, and as you can see, it helps you a lot if you're doing it the right way. Yeah, speaking about value, for example, we see a lot of value, for example, if you are a junior dev, and if you combine it with Holmes GPT, you're getting a value based on, for example, I'm junior dev, I'm stacking. So what I'm doing, I'm asking a senior dev or a senior platform engineer, but in the most cases, they need to wait for my time, maybe 1 week, 2 weeks, if they are happy, if I can jump on a call with them. So what they're getting frustrated, they are waiting, they try to Google it, they try to use ChatGPT, but they fail because they don't know how to ask. I mean, you can't just say, hey, ChatGPT, solve this for me. You also need some instruction or also some content. And we find out if you combine, for example, Holmes GPT And also with a junior dev, it also helps you a lot. Not just only the junior dev gets happy, they also learning from the agents you are using how to debug, how to troubleshoot. Because of course, for us it's very easy to say, okay, I have a problem, kubectl, get events, describe deployment, stateful set, jump into the logs, metrics, profiling, tracing, all the stuff, yeah. But if you are junior, where to start? So it helps a lot. It's really generating value for us. As you can see, we can recommend this solution. It's very easy. It's broken nothing because Holmes GPT just investigate. And also speaking about the value in the roadmap here, we can say code generation works very well, especially if we are using it for policies. If you have a lot of policies for different customer, you can say generate for me, for example, a policy for this part, and you're getting 95% working solution. You need to optimize on some cases, but it's save you a lot of time. And also like for bootstrapping, if you have a new colleague onboarding, you don't need to say, okay, let's jump on a call, I'm going the onboarding with you, go to the docu or use continue dev and ask how I can bootstrap the cluster and go it through. It also helps a lot. Investigate, like I say, we see also a lot of value to provided you detailed instruction, how you to troubleshoot, and you can use it for every use case. We use it for the most, of course, if something breaks. Self-healing, it's gonna be okay. It's from the engineering point of view, really interesting, but you need to use it, for example, with GitOps and pull requests. Don't auto-approve it and don't give too much access to the agents running on the Kubernetes cluster and fix everything they found it, because sometimes they fix things you don't wanna, that are gonna be fixed. And yeah, and pipeline and all MCP stuff and other stuff coming on the market now, we are at the research and development. And it's like, yeah, it's nice, but the most customer of us are struggling at the point with how they put their documentation on it, because a lot of customers have huge documentation over the 10 or 15 years, and they need to integrate it in a solution like private LLMs, so they also can getting a, not Syrian solution, I don't like the word, but something they can rely on it, and they can also do all the checks if you are running for the Cloud Act, for the C5 to start. If you are working with German customers or European customers, you know the pain maybe. Yeah, it's very easy. If you say it, it's very, the most things are self-hosted. So key takeaways, if you have too many agents, they are going, it's like you're giving them magic mushrooms and they get to hallucinate you. It's remind me on a story if I said I was in Venice and I saw a suit for a wedding, and 2 weeks later a lot of colleagues ask me, marriage, why we are not invited? I say, okay. So similar happening here, it's, the output is horrible. And the agents are only as good as the people who build them. Like I say, senior developers create senior level agents. So if you're junior, try to create an agent, it's also escalate. You need people that have suffer all the stuff or going the hard way, building them, and then the junior developer can getting some values from that. And also, for example, we see if you have more restriction, like I show you in the more complex use case with the multiple comments, it leads to better results for specific use cases. But if you want to explore, like you're doing a brainstorming session, so fewer restriction helps you to explore, to see what is possible, to doing some kind of chaos engineering and not to do chaos engineering, not on purpose. Yeah, this also allows you for broader solution effectiveness. And the last point, or not the last point, is going to be never trust AI. Sometimes we expect it. AI say, I fix it for you. We are taking a look on it, and then it tells us, yeah, I fix it. And you say, no, you don't fix it. I say, oh, I forgot it. I'm going to fix it now. Again, the agent is running, say, I fix it. You also take a look, and you say, you don't fix it. And they say something like, oh, sorry, bro. Now you have to fix it. And you say, okay, thanks, why I'm using you. So never trust the AI. Really, it's something like, and I don't know what's happening, but OpenAI putting some slang in ChatGPT and all this stuff. You're getting some solution like I say, so something, so sorry, bro. And you say, wow, what's happening? I don't enable the memory feature, so yeah. And you can take a photo of that. It's going to be some stuff, some references, also all the demos, 5 minutes. And GPT script also how we build different agents for different use cases, which works well, which not, because I just have 30 minutes, 25 I think, and 5 minutes for Q&A, and also Homes GPT, GPT script, a lot of videos. Last slide, I'm gonna giving a book signing on Wednesday and Thursday. I understand a little bit of AI engineering and all the stuff, but it's not my area, to be honest. I'm not an expert in AI engineering, I'm just using it. I'm in the GitOps area and platform engineering, IDP, all the stuff. So if you want to grab a signed copy, visit us at the Loft Labs stand on these 2 days. And if you have some question, also follow me on LinkedIn or just drop me a DM or connect. And if you have platform engineering related topics, I'm also ambassador. We have a huge community. I think now about 25K people are joining us. They discuss a lot of what's going on in the platform engineering area. Also join us. Yeah, and if you have some question and answer, I hope. It was a lot, I know, but I try to compress it and give you things that works out for us, not works out, not this Gen AI hype, VC founding stuff to get some money, just real experience. So thank you.
So you still have, I would say, like 4 minutes for a Q&A.
First of all, thank you for the great talk. Do I understand correctly that this is something that you built for your customers and for you to use? So it's not a product that you're selling, or?
The HomePod AI is a solution, you can join it, it's for free. But the agents we are building, they are for our developers and for the customer, and we building some catalogs, but they are only internally used. Maybe we are gonna expose them in the future or making public, because we try to share everything, and the people who knows me and follow me on Medium, and then we share everything. So maybe we're gonna share.
Okay, and second question, how much of that is like open source tools pumped together, and how much is it custom software that you developed?
The most tools, I think 95% are based on open source tools, and the middleware, the logic behind it, it's gonna be written by our developers. I think maybe 10, 15% and all the stuff. So yeah, based on open source.
Okay, thank you.
You're welcome.
Any more questions? Okay, then I would say I'll let you free to go for the lunch break. Thank you so much, Artem, for your talk. And yeah, so see you in 2 hours for the next talks here.
Well, welcome back, everyone. I'm Dor. I'll be moderating these afternoon sessions. I hope you're all fed up, your pods are healthy, and you're ready to kick back and enjoy some of these sessions. We'll start with Wojciech. Thank you.
Okay, so hi everyone. So today I want to talk about securing AI ML workflows and packaging AI ML applications and running them in the Kubernetes environments. Some challenges, some interesting problems we run into at ChainGuard, and some of the interesting solutions that we've hopefully done for them. So my name is Wojciech Kocjan. I am a senior software engineer at ChainGuard. I live in Kraków, Poland. This is my email and this is my GitHub handle. I'm also on the CNCF Slack if you ever want to, and Kubernetes Slack as well, so multiple Slacks. If you want to reach out to me after this talk and chat about some of the problems mentioned here or anything like that, feel free to do it. I'm usually trying to check my Slack, and I have it on my phone. Right, so AI ML and containers, right? So there's quite a lot of fun problems that we run into there. And I'll start with like a brief description of what containers are. I think everybody knows this, but it's really interesting in this aspect. So, I mean, the whole concept of container is that we package a subset of the runtime without the actual kernel, but the runtime libraries. And the idea is that this is portable, scalable, efficient, it's isolated, it's reproducible. But also one thing that's not in this slide is when we think about containers, they're usually quite small. When you think about, I don't know, your Golang microservice, this would be a few megabytes of a binary, maybe some SSL certificates files, some basic operating system libraries, and that would be it, right? But then when we think about AI ML images, it's a very, very different world. So the first problem, the challenge that we noticed when we started packaging them is the size, right? So as I said, like, I'm used to the idea. I was using, I don't know, Argo CD, a lot of tools that would be Golang based or even other languages based, but they would be small, it would minimum. Packaging them or just running them would be very easy. There would be very little dependencies, and usually other than the Linux distribution, there would be very little vulnerabilities as well. It would be very, very easy to just keep them running, update them when needed, when there's a new version coming out where there's a vulnerability. It's just easy. And AI ML is basically shipping everything. So we'll talk about what everything is in a bit, but it's quite normal to see images that would be several gigabytes in size. And keep in mind, I just mentioned Golang could be a few gigabytes, like a small Golang Hello World application would actually be a few gigabytes, so 1,000 times less. And one other thing that was really interesting that I didn't think of until this is specifically about PyTorch. I'm going to mention PyTorch a lot. It's my fun project to be working on it. There is this combinatorial explosion of all the things that come into the image. So one thing is the application itself, and with PyTorch, that's not just PyTorch. I'll have a slide on that as well. But it's like which features of PyTorch. There's a ton of libraries, so there's also which features of those libraries. And just as an example, if you ship anything like an ImageMagick or any other library, there's like 100 configuration options that compiled out for us as well. Then there is Python, right? I have a slide on that. I suppose there are 5 currently maintained versions of Python 3. And with AI ML, a lot of code bases are complex enough that you can't just keep on switching to the latest Python version, especially if you're also running your own code that may not be easily portable, or some packages may no longer be there. Like you need to, in many cases, you just need to do some updates to your code to have it running on the latest version. And GPU support, again, I have a whole, probably slides on that actually, and it's another difference. So if you build, say, TensorFlow, just to make it a bit different, TensorFlow is built a bit differently for CPU and GPU-based workloads. So this is also like two separate worlds that need to be dealt with. And on top of that, with GPU, there's also hardware support. So, for example, in many cases, the versions of the NVIDIA drivers, when you think about NVIDIA CUDA, they're tied to the hardware that's being run, or not all the drivers support all the hardware. So there's this whole matrix there also with what's supported. And there's also Intel versus ARM, which is a very recent, well, not recent problem, but I think nowadays it's more of a popular problem than it used to be, right? So as a fun thing, I tried to ask AI to generate what an AI ML container would look like, and this is what it came up with, and I think it's quite accurate. So yes, it's bigger than anything else in the room. There's a lot of fans that are not fully working. And there's something outside the containers, which is the integration with the host drivers and everything. So I think that was quite accurate. Right, so okay. So as I mentioned, size was the first problem. And with size, we also can talk about minimizing the number of CVs. It's not always 0, but it would be the ideal goal. And we can talk about some of the problems, right? So reducing the image size, okay, one obvious thing is the more you disable, the smaller the image gets, because if you just package the bare minimum application, it should be much smaller. But in many cases, it's not as simple as that, right? So we did manage to get one of our images down by around half, which is, I think the number is quite accurate. It was from 12 gigabytes with of the upstream image down to 5. There were some things we removed, but it's kind of an interesting. So when we started packaging, this is again specifically PyTorch, we tried to figure out what's the minimum set of features in the image that we could ship so that our customers could use it. And then we tried to decide, okay, if this is not enough, maybe we should also start including some other features. Or this is kind of like an iterative process; it never finishes. But this is exactly the question here. Like, how do we decide that? And the answer was, let's start with something a bit more minimal and start adding things once we have requests for that. And there is also another problem that I probably should spend a bit more time on, which is PyTorch again is a slightly different beast when you run it on your own, which, for example, we do have a PyTorch image, which is just PyTorch. But also there are other applications like Triton, and I don't remember which ones right now, but I believe there were at least 2 that we looked at that also ship PyTorch. And with Triton, I believe, I don't know if this is still the case, but the PyTorch had to be patched, and also the set of features in PyTorch may differ. Like if you want to run it on its own, it may be a very different PyTorch that goes into the Triton, into an image that also ships Triton server. So there's a lot of challenges around features, and I'm not going to give you one answer. I'm just going to mention that a lot of it is trial and error, and I think we've done a reasonable job of trying to get it to a set of features that work for most cases. But it's like we're still evaluating how do we do that, which ones do we enable, which ones do we not enable. And the size and like reducing features and everything brings us to the next topic. So, I mean, at Shengar, we try to package applications with as little CVs possible, ideally 0, but if not, then at least a very low number of CVs. And again, when we are shipping the whole world, and when we are basically including a bazillion libraries, Python with its own dependencies as well, and Python libraries, it's very challenging, right? So in one of the cases, by trying to reduce those things and also just trying to package things a bit differently, we got to a point where we had an image with 0 CVs. In some of the images, it may be much less than upstream, but we got that image that was over 1,000 CVs that I mentioned earlier to 0, which was quite a successful thing to do. And the way we've done it, and I believe there's another slide for that as well, is at Shengar, we ship our own Linux distribution called Wolfie, which is basically designed to be more fitting for the cloud native era. And what we do is it's using EPK, so the same package manager as Alpine. It's using glibc, which makes it a bit faster. Like compared to Muscle, it can be even 50% faster in some cases, but in general it's a bit faster. And what we do is, instead of having like releases twice a year and LTS releases every 2 years, you have a rolling release that ships all the packages all the time. And for most packages, it's basically whenever there's a new version, even without any security changes, just new functionality, as long as it passes all the tests, then we update those packages within 24 hours. Well, okay, that's not the SLA, but it's our goal to package them as soon as possible. And with that, for example, when we ship PyTorch, we would be having the latest version of ImageMagick, we'll be having the latest version of all the system libraries, and that on its own helps a lot with CVs, especially, again, when we are shipping a very large number of libraries that come with Python and all the libraries, and like image processing, video processing, audio processing. That is shipping a lot of dependencies. And again, by reducing the set of functionality and trying to focus on the minimum working image with enough features to to satisfy our customers. We also reduce the CVs because again, we may not be shipping all the dependencies that would be shipped otherwise. So that helps a lot. And again, everything and every transitive dependency, so like Python package for image manipulation may depend on ImageMagick, which may depend on some other libraries as well, will help with the reducing the number of CVs. So it's an interesting battle where we try to decide on the minimum set of features versus the actual usable functionality of the app, and it all is like this. And I'm talking a lot about PyTorch because PyTorch is what I've spent a lot of time on and trying to figure out some of the aspects of PyTorch and the version manage and the versions and the features there. But it applies pretty much to all of the AI/ML applications, and the more complex the application gets, the more checkboxes, tweaks, and settings that apply to it. Right, so apps, features, versions. Let's drill down into what I mentioned previously, right? So yeah, so this is me or anybody at Shingar trying to decide how to package any of the apps, right? And again, PyTorch, just because I know it. So on its own, it's quite large, and this is the core package. But there's also a lot of packages related to or separate applications, we could even say, because they're quite large, related to specific features like Torch Vision, Torch Audio. I can't remember anything else from the top of my head. There's a few of them, and each of them is quite large. Each of them has its own set of dependencies, and some people may want to use it, some people may not. So it's a challenge which ones to pick, right? PyTorch is not okay. I'll introduce what version streams is. Version streams is an idea often found in Linux distributions and just packaging software. This means many applications would be maintaining multiple, let's say, minor versions at the same time. So Kubernetes is a good example where we think today there are 5 versions of Kubernetes from 128 to 131, 32. To be honest, I lost track of it a bit, but some AI/ML applications also have version streams, which means we have to package multiple of these apps. And again, yes, Python, I mentioned that. 5, I was correct. So anything from 3.9 to 3.13. And many applications do work with the latest versions, but that's not enough because sometimes we also need to package specific versions because, again, people may be running models or people may be running code that requires an older version. And it's not trivial. So this may mean that we will actually be shipping multiple versions, right? So, and this is not all, right? So I mentioned GPU hardware. For many apps, GPU and non-GPU applications behave very differently. TensorFlow is packaged differently. PyTorch, for example, from what I remember, loads different Python libraries or doesn't load some libraries unless a GPU is present. So we could package the same PyTorch, but then, for example, without GPU, we can't properly test the GPU functionality, or we can't even test if it loads. NVIDIA drivers. This should be a whole set of slides on its own because it's an interesting problem. So when we started looking into this, NVIDIA drivers were more challenging than today. Right now, there are 9 versions of NVIDIA drivers that we're looking at. So 11.8. And then anything from 12.1 to 12.8. The nice thing is, recently NVIDIA introduced the compat libraries. Maybe I'll explain what the problem with NVIDIA is. It's not on the slide. So the challenge is NVIDIA drivers have to match the host drivers, and the host drivers map all the way to hardware. So in the past, when you would be spinning up an AWS instance or Google Cloud instance or Azure instance with a GPU, it would come with a specific version of NVIDIA drivers, and then your version on the host, and then your version in the driver in the containers has to match the host. So we had to ship very different versions of drivers based on what the customers may be needing and where they would need to be running it. I believe the drivers could be older than what the host provides, so that's why shipping 11.8, which is quite old, was a good choice. Now, from starting with 12 point something, and I don't remember the exact number, NVIDIA started shipping compat libraries, which make it easier, because then the driver could be newer than the host. But I remember initially we ran into some issues with it. I believe now it's no longer a problem, but it has been challenging to sort this out. And then again, Intel versus ARM, it would seem like it's just a compilation issue, but if you Google for specific versions of GCC, I believe anything below 12.5, and ARM and some include files, you find out there was this change in GCC that broke all of NVIDIA compilers, and we had to do some patching around that. So ARM, being a relatively new platform for GPU workloads, has a lot of problems that need to be solved. And again, based on those two slides, like ideally, we may want to provide all the variants of drivers, Python, applications, their version streams, GPU, CPU, but that's not what we are somewhere in between doing that and just shipping the latest, but we really want to be choosing the reasonable subset. And I believe just for PyTorch alone, we package over 20 different versions of the same version of PyTorch, because we package multiple versions of Python, multiple versions of the NVIDIA drivers, and also at Chengar we provide developer and non-developer images, I mean developer and production images, where the developer ones include additional packages, so that comes to over 20 different versions of the same image, of the same PyTorch that we have to build and test. And again, like coming at this image, what we would really want is to ship one version that is working for everybody, but it's not the case, so we ship a lot of various options and combinations that we have to deal with. Yes, and then actually I do have a few slides on GPU. I just don't have the charts of the support matrices for the drivers and everything. So one other thing we realized is testing the images is very different and quite challenging. So, and by the way, this is the Wikipedia image of a smoke test. This is where the word smoke test came from in the 19th century, where pipes were just tested by pushing smoke onto them. I had no idea until they've made those slides. But when we think about smaller images, again, going back to even Argo CD, the way you would test Argo CD end-to-end is to deploy Argo CD, have it deploy some different applications, like a Helm chart, like maybe something from Git, and basically point a browser or at least a curl towards some of the endpoints of the applications and see that they work. And it sounds complex, but to be honest, with a reasonable CI system, with reasonable automation, it's something that is very easy to do, and it's something that we do on a daily basis. And with GPU images, it's very different because, well, AI/ML apps have a lot of have quite a huge scope. So yes, we can test the basic things. We can test, I don't know, entry points. We can test that the applications load. That I don't know if I call tensor torch.tensor when it generates, or tensor.rand when it generates a random tensor, and it's actually loading enough libraries to talk to the GPU. I can test it this way, or we can test it this way. We can automate that, but that's not really what our customers would be running. So, for example, an ideal test would be that we run a learning of a model and benchmark the time that it takes, benchmark that the results from that model are more or less similar, because AI is also non-deterministic. So we can't write the test where we teach it a model and then expect the model to always output exactly the same thing, but we could at least expect that the learning is successful and that the result is within a set of results we think are reasonable, which if we, I don't know, calculate probabilities or a simple one-dimensional result, it's actually doable. We are not there yet, to be honest. We have reasonable tests in place for AI/ML images today, but I think what would be ideal is very far from it. And again, like testing GPU, non-GPU, our pipelines are more optimized towards testing non-GPU workloads. So we do test the non-GPU features more extensively in the pipelines. For the GPU test, we also have some automation in place and test them, but it's very challenging. It's really difficult also to figure out what to test and how to do it. So that if we build those 12 images, how do we run them without this running for multiple hours and being a very challenging thing to maintain and not be flaky. We don't test on all the hardware either. We test it on a subset of the hardware. We try to figure out where to run it. So right now, we focus on Intel, but we do have some tests for ARM as well, and we use public clouds, which is also kind of problematic, because one thing that I also expect, and this is mentioned here, is I'll start from the end of the slide because it's better to segue from there. If anybody is running something not in the cloud, we would have no way to fully reproduce that in an easy way. So we kind of try to figure out what's the best way to run things, what's the most common hardware across cloud that we should be testing. Obviously not the NVIDIA 5060 Ti, but it's a challenge to figure out all the scopes that should be tested. And yeah, so for now, the upside is for building, we don't actually need the GPU. So building the packages, building the images is quite easy. We just compile all the things from NVIDIA 10 to all the way to PyTorch. It takes a while, but it does build. And the NVIDIA compilers do not need a GPU to compile for all the variants. So it's quite good. That part is quite easy to do, but the actual testing of it is the challenge. So today we use GPU instances across 2 clouds to test those images. But like I said, ideally we would want to have a better coverage. It's just we are still trying to improve all the pipelines. And I think that's the case with everything at ChainGuard. We've been packaging images for a while now. We've packaged quite a lot of them, but it's still something we are trying to improve. And AI/ML is quite challenging in that aspect. And right, and performance. That's what I mentioned. I don't think we do enough of testing of performance. So we do run the learning. We do run teaching the AI models to benchmark the speed. And there was actually quite an interesting fact that we realized when we did this. When we started experimenting with this for quite a while, we realized that using VNF, at least for PyTorch, made it much, much slower, which was very surprising. So I don't know how many of you use or package Python applications. VNF is a tool that allows shipping all of the Python packages in a subdirectory of an application, which makes it easier to, for example, ship multiple applications at the same time. And when we mentioned PyTorch being shipped along with Triton server or anything like that, this makes it a bit easier to manage dependencies. But we also realized that the performance difference was quite significant. I believe it was 20% slower, and we couldn't get to the bottom of why it's slower. But basically, shipping the libraries in USLib instead of shipping them in a VNF was just significantly faster and even in longer running processes. And this was one of the interesting findings that I don't think we ever figured out why, but it was something we stopped doing because of that. And it made a big difference in terms of how the images were running. And again, because packaging something and running some manual tests would be easy, but then getting to something that's fast, efficient, and well tested and has consistent performance was a bit more challenging. And I believe that is it. So thank you, everyone. Questions?
Any questions?
So I'm just curious how you maintain this entire environment and how you keep things updated.
So what we do is somewhat separate. We don't usually maintain all of environments. The way we build everything at ChainGuard is we split into 2 steps. So we compile the source code into binaries, which are basically the APK packages. And for that, we don't even need the GPU, as I mentioned. This makes it slightly easier. The packages would have some tests, so we would actually test that the Python library is loaded, at least without the GPU at this point, and we can do that in any. Well, we don't use GitHub Actions or anything similar because of the scale, but we do have our own build environment that just spins instances one up and down for any single build, and that's also for security reasons, because often we would be literally cloning random code of the internet and compiling it, so we don't want to keep anything like that persistent across builds, not to contaminate them. But this is all set up and tear down per build. With the images, it's very similar setup. We build the images, we have our own tools for that just basically put an image based of multiple APK packages together, and then it's a valid OCI image. And for testing, we also spin up and tear down the environments for automated tests. like I said, we don't have all the automation in place. For some of the tests, we have manual documentation for the more complex ones. And then it's like before we release, there is a lot of automated tests being run. But today, for some of the more complex testing flows, when we, for example, refactor the application, we would have an engineer spin up an environment according to documentation, so according to specific, I don't know, say specific image in a specific cloud with specific GPU type or specific GPU types clouds, run some tests documented there, and that would be the criteria for it. For example, merging that change to an image in and then having the automation build it again. So that's more or less how it works. But we don't maintain the environments. It's more about setting them up and tearing them down dynamically. We're now moving more towards using the cloud managed Kubernetes clusters for these kinds of tests, but it's still a work in progress. There's a lot of things, like I said, that we want to improve in testing.
Thanks for the talk. You mentioned that you've been working with NVIDIA GPU specifically in trying to add hardware support. Have you also looked at the AMD side, specifically ROCm, and what kind of experiences do you have about that then, if so?
Sadly, no, the focus has been on NVIDIA so far. So just NVIDIA.
Any more questions? Okay. Thank you, Wojciech, very much. The next session is at 2:35 p.m. So next up, Alistair and Edith on Kubernetes from the database out.
Thank you so much. So hello, everyone. Good afternoon. So today we are going to talk as Kubernetes from the database out. So I'm Edith, and here we have Alastair. Next slide, please. I work for Percona, as you see the t-shirt here. I am tech evangelist at Percona. I am also part of the QA team for the Percona Everest project, and I am CNCF ambassador. We have Alastair.
Hi. So I am a database nerd. I've been a database nerd for a very long time now. What I currently do as a database nerd is that I'm a tech evangelist at Percona. I really did try to avoid this whole new cloud native infrastructure thing for a while, but come 2018 it caught up with me, so Kubernetes has been part of what I've been trying to talk about along with databases since then. Why this presentation is really that a lot of the introductions to databases on Kubernetes start with things in the Kubernetes order, all these little building blocks, and by the time you've figured out how they build up 7 layers deep, you've forgotten why they matter to a database in the first place. So the idea behind the running order and the structure of this is to present bits of Kubernetes to you in the order you'd see them if you'd been given a managed database on Kubernetes and now needed to interact with it. So some of this is about the terminology. Yeah, it's important for database people to talk to infrastructure people in terms we all understand. But on the whole, it's just a different perspective, a different order of looking at some of these things, which is hopefully interesting, and yeah, you can learn 1 or 2 new things from.
Yeah. As Alastair said, we are going not to talk about the natural order that we already know, but we are going to start for another component. So the first thing that we are going to see is how we are going to try to see how to connect it to the database. We are going to see what is the query for the database, and also we are going to see the Kubernetes commands. Alastair has a database background. I have a DevOps background, so this is a great opportunity to match that both knowledge, and we are going to see it in the presentation. We are going to see also querying, recovering, and how when something breaks, we are going to see how to see the logs, what tools we use to see the logs, and we are going to see deploying and scaling, how we can see that kind of processes in databases, and then a time for QAs, for questions. For our environment, we have PostgreSQL cluster with 3 nodes running. On Kubernetes, we use our favorite database, PostgreSQL, the version 16.4 running on GKE. So we deployed this using Percona Everest, which is a cloud-native solution to run databases on Kubernetes, to manage and to provision. It's free, it's open source, feel free to involve and to send feedback as well.
Right, so just in case there is a prize for the presentation that gets to the command line quickest, here we are on slide 5. So if you are a DBA, you've been handed a set of credentials for a managed database on Kubernetes. What does this look like? What do we see? So we've been given an IP address, given a password, we can log in, nice and easy. Also, just by the way, since the demo gods I think are under enough pressure today, we've decided not to place any more strain on them. These are all pre-shot, obviously. If we have a look at what the database knows about our connection to Postgres, so for our process, the application name is PSQL, it's the client library, that looks right. The IP address doesn't look right. This is not an address outside, this is a private address, and we'll see why shortly. The other place that you may find some information from Postgres about its networking is where it's listening. It's listening everywhere. Everything that Kubernetes forwards to it, it's processing. And we can now see on the Kubernetes side how all of that gets to us.
Let's see Kubernetes commands, Alastair. So if we list all the services that we have in our Everest namespace, where our cluster of Postgres is running, we see that PostgreSQL PG Bouncer is there, is the type of load balancer, so it has an external IP. That external IP is where Alastair just made a connection for the database, for Postgres, and PG Bouncer is special because PG Bouncer acts like a proxy for a database. It means that instead that the applications can make direct connection to the database by one, PG Bouncer try to reuse the nodes, a small amount of nodes, so to make everything more smoothly and more simple and efficient.
So if we then just sort of look at what some of the things are behind that networking, we had a load balancer there. The networking for Kubernetes to forward traffic to a service is important because when we have multiple instances of a thing like Postgres, when we have a distributed database, when we have primaries and replicas, they need to have stable addresses. The replica always needs to know where the primary is to connect to and get the data from. So instead of workloads spinning up with new addresses every time, as would normally happen inside the Kubernetes cluster, we need a stable place to address them. That is provided by a component of Kubernetes called kubeproxy, but if you're just thinking about this with a naive networking hat on, you'd think, okay, kubeproxy gets the data and forwards it. No. What kubeproxy does is it configures the kernel of whatever operating system you're running on to do all of that forwarding. So if kubeproxy, for instance, did go away, all those forwarding rules remain. All it does is keep the kernel networking up to date and running on time. So that's great if you have an application inside the same Kubernetes cluster trying to access the database. As soon as you try to move a little bit further outside the cluster, as you would for a database as a service system, you need exposed connectivity. That's provided by the node port construct. So this will expose a port for you on every node in the cluster. It won't be that 5432 that we expect to find Postgres on, because in that case, we'd only be able to run one Postgres inside any Kubernetes cluster. It's a port that's assigned from a range. In order to now make this accessible in a way that the application expects on the right port, do all the things around balancing across primaries and replicas, you would put a load balancer in front, and it would do the health checks on which bits of the cluster to connect to, which is where we were for our example. Now, once we've connected, we need to query. If we are working with enough data, or if we're writing any data out, and we want to get to that important aspect of a database that is durability, we need some sort of storage to work with. In much the same way that on a Unix system, you'd take a device, you'd mount it to a path, and that's where you'd store your data. In the Kubernetes world, there is some persistent storage out there, called the persistent volume, and you claim it. Similar kind of idea, new set of words. Persistent volumes are not normally created from scratch, by hand. They're created automatically when a claim is made that isn't satisfied. So you will hear, or in discussion with infrastructure people, the idea of a PVC used almost interchangeably with the volume itself, because they're often only created at the point at which they're claimed. And this whole process of getting the storage in the first place is done by a set of software called the Container Storage Interface. So this is the standardization that allows Kubernetes to perform the same set of actions on top of any piece of infrastructure. One of the more interesting things from a database point of view here is that a number of the CSIs give us the ability to do snapshot cloning. So when we're trying to create replicas of a database, instead of having to copy all the data off one volume, write it back to another, we can just take a snapshot of the volume and spin a replica up immediately on top of that same persistent data. So from minutes or hours down to seconds, which is a great benefit to sysads to database administrators when building clusters or when upgrading them, which often requires rebuilding replicas. So if we have a look at what Postgres thinks about its storage, we see the storage directory is the default. So this is where we'd expect to see the storage from Kubernetes mounted. The other bits which would show more detail about where the storage was, the temp table spaces or the contents of the PG table space system catalog are all empty. So what we can see for this particular setup is that everything is under that PG data mount point, and that's where we'd expect to see all the bits from the Kubernetes cluster mounted. On the Kubernetes side.
Amazing how it looks in databases. I always wanted to know how is inside databases, what is happening. So let's see what is in Kubernetes, how it looks. So if I make a list of all the persistent volumes that I have several of them. So they are like storage, pieces of storage in the cluster. And we have in the bottom persistent volume claims. It means that we are going to try to request that storage that we have for the persistent volume, and it's going to be bound to the persistent volume through the ID of the persistent volume, you see. So all of these claims, as you see, the persistent volume claims has 25 gigabyte, right? Gigabyte, and all of them are have an storage classes of standard read-write only. Also, we have, if we select one of the pods and we inspect all the volumes of our pods, we have several of them. This is just specific for our PostgreSQL database. So if we see the main and the most important here is the Postgres data, is where our data, all the data we are going to store in the database is going to be there. The other volumes that you can see are for things like backup, like restore, that temporal files, for example. If we see the storage classes that we have for this cluster, we found three. The standard read-write only is the default one, and it depends of the cloud provider that we are managing, and also depends of the on-premise setup. So it depends of us to ask which storage class is optimized so we can run databases on Kubernetes with a specific storage class.
Yeah, so just following on from that about the particular storage classes here, what's interesting to see is that we do have an option for going faster. There is something called premium. Presume that'll go a bit faster than the standard we've been issued by default. And looking at all of those mounts into the container, so Postgres data is what we'd normally think of in the database world as persistent storage. It's a volume that we can put data on and go get it back later. A lot of those others, like the certificates, like the PG backrest config, they aren't real disk. They're read-only mounts of data that is managed by the Kubernetes cluster about the configuration of Postgres, about the configuration of PG backrest in that case, or about the certificates that these systems are supposed to use for authentication or for encryption. So Edith mentioned at the beginning of her explanation the idea of a pod. This is generally where any discussion about Kubernetes starts. And I think we've got about as far into any discussion about databases and Kubernetes as we can without mentioning the P word and explaining them in a bit more detail.
Yeah, We started explaining services, starting explaining others. Now it's time to explain about pods. Pods are pods of PIAs. It's a group of containers that are managing together. So they share. We can have one single pod running usually in one single container running in a pod, but we also can have several pods running, several containers running in a pod. So in this case, for our demonstration, as we see, we have several containers running in a pod, and they share the same. They can share the same storage. It means that one container can access the storage from another, and the other for the other. They can share the same networking. It means that they can talk each other through local hosts, and they are limited by the resource constraints for the resource constraints. It means they are limited for CPU and memory for the container. So if we see the Kubernetes commands for this, we list all the pods, we inspect the pod that we have there, and we inspect all the containers that we have. So in this case, we have 4 pods, 4 containers, for example, and the main one is the database that we see here. And we have, for example, PG backrest. So they are both 2 containers running in the same pod, and they share all the resources that I am mentioning.
And the reason there, for instance, the PG backrest one being in that same pod would be important is because they need to share access to that underlying volume. Your backup process needs access to the same storage that the database process has access to. So as we start to build these distributed systems, one of the first things we need to deal with is what to do when things go wrong. In the past, we had mainframes, tandems, sequence, all of these big machines trying to avoid anything ever going wrong, over-engineered to pieces. If we move to the other end of the scale, Kubernetes tries to maintain resilience by recovering quickly and recovering automatically when things go wrong. So what happens when a particular database instance goes away is something which Kubernetes can help us with, which can be better managed than we would be able to do it manually or with many of the other automation tools. When any of those containers inside the pod fails, so for instance that PG backrest process, the process would be restarted. If a pod on the whole is unhealthy, Kubernetes will destroy the pod and recreate it. Now that process of destroying the pod, recreating the pod, may bring it back at a different address. The question for something like a database engine is that whether the same address actually lines up to the same data on disk. And there's a construct in the Kubernetes world called a stateful set for ensuring that that happens. In some ways, it makes sure that the processes you're running inside containers behave a lot more like you'd expect a process to inside a VM. It just is a lot more stable. So we end up using a lot of the same tools we do for managing HA and DR of databases in the VM world. For Postgres, it's Patroni. So the Patroni system knows when the primaries disappeared. The Patroni system promotes the replica. There is an alternate view on this, which is if we're doing this all inside Kubernetes, if we have Kubernetes knowledge of the health of all of these components, why aren't we leaving it up to Kubernetes? And the challenge there is that a stateful set doesn't have any construct for knowing what the role of each of these pods is. It just knows that they're all there. It knows what order they need to start in. So some of the producers of operators for Postgres and Kubernetes have chosen to move away from the stateful set. They've put a lot more code into the operator, and the operator manages not only the role of each of these instances of Postgres, what's a primary, what's a replica, the promotion, but also the health of them and managing the restarting of those processes. So it's fewer Lego blocks, but more control, which is always an interesting trade-off. Now, when something does go wrong, the first place we're going to want to go and look is the logs. So knowing how they last, where to find them, would be interesting.
Let's see about logs. So usually the databases save the logs into into files, but when they are running in Kubernetes, they write the logs in a standard output, a standard error. Also, they are safe in the node. So if something happened to the node, so our logs they are gonna disappear. We can see the logs with kubectl logs and the name of the pod. And if we want to do something better with the logs, like compilate the logs across the cluster, we can use other custom plugins and other tools to help, for example, to visualize these logs better and also to give it a better format.
Right, so one of the things, actually, probably missed one of their slides, one of the things about using a tool like kubectl and using the cluster to manage the aggregation of the logs is that we don't need to get involved in things like log rotation anymore. It's not, what's the period of this log, what's the file name I need to go looking for this particular time period. The fact that they're all managed behind a single interface provided here by something like kubectl allows us to just give it a date range and go off and do as we see fit. So we see here the config on our test cluster. It goes to standard error. There is no information about log rotation, so this is all just being left up to the Kubernetes cluster to manage for us as it sees fit. And the logs at least will outlive the end of the pod. We know that they're stored somewhere more reliably.
So let's see now how it looks logging in Kubernetes. It will list our pods, and we take one of our Postgres instance and we inspect the logs. We will see this, things about patroni, for example. So when we deploy the databases for this environment, it deployed everything that is necessary already for the database. So it installed patroni, which is going to help the database to have high availability, is what we want when we run databases on Kubernetes. So if we see there, bootstrapping from leader Postgres is trying to create a node from the backup, so it's going to try to secure high availability. Okay, we talk about several Kubernetes objects. Now let's talk about the start of this talk. So the Kubernetes operators. The Kubernetes operators are database logic that is added on the top of Kubernetes to manage and automate databases process. So for example, I can write custom resource definitions that are the main component of Kubernetes operator to automate backups, replicas, store, scaling, rolling upgrades, and all these components. And it make it efficient, and it's possible, and it's the way how we can run databases on Kubernetes, thanks to the operators.
All right, so just to then tie all of that together, I'm not going to read through the whole thing. There's one or two just important bits to talk about here. Firstly, those little things in bold are your bluffer's guide. These are the terms that the DBAs need to be able to talk to the infrastructure people. Just one thing right at the top about packaging. We often hear people talk about various operators for a particular database technology. We've been talking today about Percona's operator for Postgres and about Cloud Native PG. It's not just the operator. These all come with their own set of container images that they manage in a different way with different behaviors that match up between the operator and the container images. Other than that, just say, hope this has been interesting. This is an area which has become useful now. We can sensibly use Kubernetes to run databases, but it's not quite there yet. If your thing is Kubernetes and control planes and cross-cluster control, or if your thing is databases, get involved, push it a little bit, because there is certainly still some space here that we can work on together to move it forward.
Yeah, you will come to contribute to the data and Kubernetes community. So where you are working for all these initiatives to create more standards to run databases on Kubernetes better. Yeah, I think we are on time, right?
Yeah.
Okay. Okay, thank you.
Thank you very much. Questions?
Is there a trend that you're seeing between DBAs asking for this, or is it infrastructure people asking to run the database? Who's deciding?
So it's not often the DBAs. So it may be app teams. The idea of the microservices database, that you have one database with each app inside the Kubernetes cluster, is driving part of this. At the other end, it is the database engineering teams who are trying to create standardized, repeatable, low-effort deployments for all of the app teams, and that's where we see the sort of database as a service stuff play out. Those are, I think, really the two areas there. The DBAs, unfortunately, it just happens to them.
They just want a database, right?
Yeah.
And then what's the biggest challenge with running a database in Kubernetes today? What are we missing? What's the biggest thing we're missing?
So I'd like to see the idea of the stateful set extended a bit, so that example I was talking about, where some of the operator teams are deciding stateful sets are fighting against them, and they're trying to replace all of that functionality. It doesn't feel like a good thing to me ecosystem-wise. I think the ecosystem could serve stateful workloads a little better, and then we wouldn't end up with quite as much fragmentation at the operator level.
Fair. Cool. Thank you.
Great talk, thank you. Just following up on your question, I wonder, and I know it's a little bit of a naive question, but like, what's the main challenge using persistent volumes over, using ephemeral storage directly?
So, I think it's making sure that we can get the replicas back quickly. So, when we have things like snapshots, not all the CSIs provide them. The CSIs that do, we can get a replica really fast. If it was ephemeral, we'd have to wait to move the data between the machines. That said, another area where I think it's actually the operators, it's not the underlying Kubernetes stuff, isn't doing very well at the moment, is providing ephemeral storage where it's appropriate. So in a database, you have operations that spill to disk. The sort is too big, it needs to go to disk. At the moment, most of the operators still try to put their stuff on PVs. The model of trusting that there will be ephemeral storage, or testing at startup time that there is actually some ephemeral storage you can use, isn't there. And maybe that actually is another area where the underlying stuff provided by Kubernetes could improve, is providing some assurances around the ephemeral storage. Because at the moment, there's strong assurances around PVs, but ephemeral storage is just kind of try and see.
Yeah, great presentations. So there are some alternatives to running Postgres in Kubernetes. Without going into details, what would you say sets Percona apart from the alternatives?
We have in this open source world, there are several Kubernetes operators. It really depends on what your necessity is. But for example, we have Cloud Native. There is in the Cloud Native ecosystem, there is Cloud Native PG, there is Crunch Data, there is Solando, and it depends the operator. If that adjusts to your business, you can start to use that. So we don't say we are the only operator. We have several, but every operator has his own strengths. So it depends, as always. It depends.
Yeah, I suppose the key area where we are trying to differentiate isn't actually on the operator. It's that layer over the top with Everest. But yeah.
Can you repeat it to the mic? Sorry.
Oh, sorry. I'm not close enough to the mic. Yeah. So I think really the key area where we're trying to differentiate is not on the operators individually. There are trade-offs there. People have made different architectural decisions. But the layer over them to give you database as a service on top of the operator is, I think, the area where we're trying to differentiate. And if anyone is at KubeCon, I presume most of you will be, we will have a booth. Come and talk to us. And a different database product we're involved with, Valky, is having a birthday party on Tuesday. So come and get a cupcake. Should have moved it onto the queue, but anyway.
Okay, thank you very much. So next up, Yassi is going to bring the hedge right to this room, right? Go ahead.
All right. Thanks for joining. My talk is about Kubernetes, Edge, and especially forage. And as you might see from this demo setup, I mean Edge in many different senses. I like to kind of live on the edge too. So I'm going to talk about, of course, like Edge and what I mean by Edge and Kubernetes at the edge, but also like how to go kind of a bit beyond the edge, how to connect to the world of IoT and cameras and things like that when we get Kubernetes first to the edge. And Edge in general, as many of you know, there's like a set of unique challenges that we first have to figure out how to deal with. And yeah, let's take it from there. So I'm Jussi. I work at Mirantis in the Open Source Program Office organization. And what our OSPO organization really is doing, we drive things like K0s, which is CNCF Sandbox project. We work with a lot of other ecosystem projects like CAPI, Harbor, gazillion different projects where we help and some of we drive, and we're being good open source citizens in a way. Okay, so I'm going to talk about what I mean by forage, why Kubernetes in the first place on Edge, lightweight clusters, K0s, and then we're going to have a look at the resource discovery with Acri, and then I'll paint you a kind of like an architectural pattern, I'd say, blueprint, whatever you want to call it. Of course, everyone's architecture is different, so I'm suggesting things. I'm not saying you should do things, at least not this way. And then hopefully we'll have time for a couple of questions. Well, yes, there is demo, live one. So please pray for the demo gods for me. I would really, really appreciate it. All right, so Edge and forage. Edge in general is one of those things that it's difficult to have like a definition for. If you talk to 10 different people about Edge, you might get 10 different views, what it actually is and what it means. So for the context of this talk, what I mean by forage is basically the computing that happens next to the data sources like IoT devices, USB cameras on the furthest edge of the network as possible. The computing nodes could be running on smart cities in a lamppost, like in a Raspberry Pi-like device. It could be submerged underwater, which is actually a super cool use case. It could be factories, industrial automation, you name it. There's a gazillion different use cases. Oftentimes, when we're talking about Edge, and especially forage, the computing capacity gets smaller and smaller and smaller once we get to the kind of further away we go to the edge. And that's obviously one of the biggest challenges, because we are talking about Kubernetes. So it's not like super small in nature in general. And then, of course, connectivity and networking in general. At the far edge, we're usually talking about connecting with 3G, 4G networks, maybe satellite connections, and things like that. So we don't really have the luxury of like clicking a button and getting an ELB on Amazon. So we are quite far from that. And oftentimes these kind of requirements and limitations, what we have at our hands, it really drives to have more clusters which are smaller typically. And with every cluster, you get certain overhead of operational capacity. You need to manage the clusters. You need to, especially the control planes, you need to, pet them like pets and keep them happy and feed them. And so how do we push Kubernetes here? Well, why Kubernetes in the first place? I guess there's an obvious answer, because we all love it. We are at the CNCF Rejekts, so we want to take Kubernetes and push it everywhere. But, I mean, what do we need in a forage-like environment? We need to have a way to automate things, automate configuration changes, automate workload deployments. That's what Kubernetes is. So why not leverage that functionality? And with containers, what we have is, or what we get is some level of portability for your workloads. I mean, it doesn't come free. You can't take one container image and run it everywhere because of like CPU architecture or changes and things like that. So if nothing else, you need to figure out how to build your applications in a multi-architecture images. That's the least you have to do. There's probably plenty of other things that you have to take into account on your application level. Perhaps the biggest thing in Kubernetes is the declarative way of managing everything. And I mean everything. From your network setup through CNIs, your service meshes, basically everything is a YAML file or set of YAML files. So we have a good way to declaratively manage our edge workloads now. Since we are talking about edge and typically very resource-limited devices, environments, we need something as lightweight as possible. And I'm using now a term lightweight as possible because we are talking about Kubernetes, which is basically a bunch of Go programs, and we all know that Go isn't that lightweight in nature. So, like mentioned, K0s is a CNCF sandbox project now. We do have still a couple of checkboxes to do on the sandbox induction list, but we are basically there. In K0s, we've configured everything in a way that it is as minimal from resource consumption as possible. So I just checked on my running system the basic Kubernetes components on a node, which is, well, in this case, the K0s process itself, kubelet, and containerd. That's like 230 megs of RAM. So it's relatively lightweight, especially if you compare like getting an Amazon instance with 187 gigs of RAM, so then it's nothing. But on a Raspberry Pi sized device, you actually have to take these things into account. K0s is a single static binary, embedding all the Kubernetes components, everything that you need to run a Kubernetes node. So it's a super, super simple setup for your edge nodes, whether they are Raspberry Pis, whether they are industrial automation controllers, very, very rugged industrial boxes. I don't know how to describe those. Those are actually boxes. I have a couple of them at home. Because we actually worked with an industrial automation use case. And the automation controller is really sitting in the factory automation like panels. It had one single super, super slow ARM v7 CPU, 512 megs of RAM, and boom, we have Kubernetes running there. That's pretty cool. I mean, those guys, how they orchestrated things before, or orchestrated, was basically, whenever they had to change anything, there was an IT guy with the USB stick going and changing things. And imagine if the edge nodes are in a lamppost or submerged underwater somewhere, it's not really operationally efficient to have an IT guy or person in general going around with a USB stick, right? Okay, so all the resource constraints, it kind of begs the question that where do I run the control plane? Because we know that the control plane is the biggest resource hog. If you take a somewhat busy Kubernetes cluster, you look at the API server, etcd, schedulers, all that, it's like 3-4 gigs of RAM easily. So I can't fit that into the industrial automation thingy. One of the kind of unique, and in my opinion, I might be biased a bit, one of the coolest thing with K0s is that from the day one, we've had this architectural separation of concerns, worker plane, control plane. What I mean by that is that by default, when we run the control plane, we don't actually run kubelet, we don't run containerd. All the Kubernetes bits and pieces, API server, schedulers, whatnot, they're running in what I call naked processes. Your standard Linux processes without containers, namespaces, any of that fancy stuff. What that means is that the controller node is kind of actually not part of the cluster per se anymore, because we don't have to stretch the CNI networking or anything. And for example, and in my demo, the control plane is actually running on Amazon. And the worker is on my Pi. And it just works. So with that kind of architectural pattern, our edge nodes are basically pure worker nodes now. And as we all know, kubelet by itself, running and kind of orchestrating the single node, it actually tolerates quite wonky network situations. It doesn't really matter even if I cut the cables for a while. What does kubelet do? Nothing. It keeps on running and maintaining the last known state until it knows anything better. So next time, maybe tomorrow, it'll be able to connect to the API again, and it gets new information that, okay, I need to change something. So your workload actually keeps on running, which is exactly what we want in Edge. So again, one tick for Kubernetes on Edge. Of course, that does mean that we need to pay a bit more attention on our scheduling constraints for our applications. Because the API server at some point sees that, okay, I haven't seen that kubelet guy in a half a day. I'll move the workloads to some other node. But then again, we are talking about edge devices, IoT, cameras, and whatnot. So we're probably anyway pinning our certain workloads to certain nodes. So it doesn't really maybe matter that much. And speaking of connecting to IoT and that stuff, Acri is another CNCF sandbox project. They're actually entering the sandbox pretty much at the same time with K0s, which is sort of cool and kind of prompted me to do that talk. So what Acri basically is, it's a set of controllers, like everything in Kubernetes is and the whole cloud native world is a controller of sorts. It acts kind of like a bridge between Kubernetes and the cloud native, and then the IoT and device world. So basically, the main feature in Acri is dynamic discovery of things, like in a kind of Internet of Things sense. It supports different protocols out of box, and you can always extend and write your own protocol handlers. For example, OPC UA for like industrial automation discovery, OnVIF for IP cameras, and then Linux UDEV for basically any pluggable device, like a USB camera, for example. And when Acri finds those devices, it'll actually provide the information to Kubernetes as resources, which I can use to target my applications. I'll dive into the details. So everything with Acri basically starts with creating a configuration. Well, you first have to, of course, install the Acri components, but you know that's always a Helm install away. But in the configuration, you basically tell the main thing is that I want to use UDEV for my device discovery. And of course, you can have as many discovery configurations as you want. In the configuration, I can say that okay, we're using UDEV, but I'm interested in only certain kinds of devices, like, for example, video devices. It could be whatever your use case tells you to, or you need to use in your use case. For OnVIF, you basically provide like an IP range that, okay, look for IP cameras on that range. And then when we find those resources, it creates an Acri instance object or resource, basically telling that okay, I found a video device on that node. The second thing it does, it actually augments that same information into the Kubernetes node object. Remember, Kubernetes node object has these allocatable and capacity parts in it, basically telling that you have like 4 CPUs and X amount of RAM. And voila, now I have an allocatable device on the node object too, which I can use to target my workloads. And that's super cool. I'll skip to the demo. Okay, so a real live demo, everyone praying for the demo gods. I have a Raspberry Pi node. I have the control plane running on Amazon. Another project we're contributing to CNCF Sandbox is called Cosmotron, which is actually capable of running control planes within an existing Kubernetes cluster. So it's really turtles all the way down for us. So my Acri stuff is running Acri is running on my node, Raspberry node. I've configured the UDEV discovery, and it's finding my USB device. It creates the resources. And maybe the coolest thing I learned about Acri is the broker concept. So in the configuration, you can actually tell Acri that okay, when you find a device, deploy a broker bot on the same node. And the role of the broker is basically to act kind of like a middleware in a way. Because, you know, we have cloud native applications which usually don't understand or want to understand anything about devices and USBs and UDEVs and things like that. So in this example, what the broker actually does, it's the broker connecting to the camera. And the broker offers me a gRPC API towards the camera. So basically, my application doesn't know anything about USB cameras, UDEVs, whatnot. It just calls an gRPC API to get a frame. And that was super, super simple, even for me. And I'm not a Python person at all, and I was able to do that in Python. You know, vibe coding. All right. Let's see. No, what do I need to do? Why is this so difficult always? Okay. Is the font big enough? Okay. So, Acre instances, we found the UDEV device on my Raspberry Pi. And like mentioned, we have this capacity and allocatable, and we see we have one allocatable device on the node level, which means that I could actually target my application directly based on those resources. So basically, I would say that in my pod, I request that device, and boom, Kubernetes scheduler makes sense that that is actually scheduled to a node where that's available. And then the configuration. UDEV minus O YAML. So in this example, I have this UDEV this, where is it? Yeah, discovery handler UDEV, interested in video devices, and we find the USB camera, and I get the broker pod, and now my application connects to the gRPC. And of course, we all want to know what the application is, right? It's AI. So, in Raspberry Pi, the resources are very, very limited, so I cannot do like any real-time object detection or anything. So it's basically grabbing a frame from the camera every 30 seconds. It runs it through a Facebook ResNet model to detect objects from the model. And if you see yourself in the pictures, don't worry, I'll nuke it anyways. It's actually a database within the pod. So, and let's see. Let's take an example here. Oh, it's a bit badly pointed, but there's a lot of persons in the picture.
Game chairs.
Sorry?
Chairs.
Chairs. Yeah. Well, there's a lot of things in the, but that's not the point. What the model does and how good it works. Don't ask me anything about AI. I really vibe coded it together and shipped it to production. What could possibly go wrong? There's one slide I wanna show. Oh God, let me kick that away. So my colleague Prashant has a talk at KubeCon where he really pushes things underwater. So they've developed an underwater buoy to monitor sea conditions and water conditions and the algae and coral growth things. I don't really know what they do. But it's actually running a Raspberry Pi within the underwater buoy with K0s and Kubernetes, connecting to the external world with 3G antennas, solar power, all that stuff. And with that, we can push Kubernetes really, really, really far away to the edge, and we're underwater. So go see that talk. It's a super cool project. Thank you.
Awesome. So, questions?
And remember, don't ask anything about AI.
So that AI model, no, just
Bye.
Have you looked at are there any considerations of image distribution for edge nodes and stuff like that, especially if you're running this underwater kind of thing?
Yeah, that's a super good question, and of course, especially now if we think about AI and stuff where the images grow like exponentially, you have to figure something out. I don't have an answer because it all depends. It depends on your networking conditions, whether you actually can even pull any images. One of the things in K0s that we have is K0s can actually, if you have a tarball of images in certain location on the disk, when K0s boots, it actually loads them up automatically. So that's one way where K0s can help you at least. But it really depends on your networking conditions and whether you have like a decent enough speed to pull images from your private registry or something. But it's a difficult problem quite often, unfortunately. I wish I had a good answer, but it depends.
Hi, thanks for a great talk. You mentioned in your, or showed off in your demo, the support for grabbing video frames off of USB cameras and then exposing them through gRPC. What else can the broker do? Like if you plug in a USB keyboard or mass storage device or something?
Yeah, anything. I mean, the broker running, it's just a pod. And in the Acri configuration, you actually tell that, okay, what is the image and what is the configuration that for the pod that you want to run. In this example, because it's a super simple example, it's just like connecting to the USB device and getting the frames for me, and that's it. But you can write your own brokers, you can write your own discovery handlers, you can really customize and extend Acri itself, where it actually becomes more like a framework in a way.
All right, thanks.
Thanks for the great talk. One thing, normally the kubelet has a problem when you reboot. Is this solved in K3s on the worker side, or is this something?
In my experience, reboots can be problematic. For example, in my demo setup, I've had 0 problems with kubelet at reboot. I've had a lot of trouble with Acri on reboot and the UDEV and all that stuff. But honestly, I haven't really seen problems with kubelet per se in reboots.
So it would start the containers again?
Yeah, yeah. At least, usually. When what I actually mean by that is that you know, kubelet, containerd, and everything they are kind of dependent in their surrounding environment. I mean, if everything is okay in the Linux system in general, like you have your clock synced, and you have your storage in place and file systems initialized and all that stuff, then it should work.
And if you to this time are disconnected, then it's also doing the same, or did you do some special there?
No. Kubelet is the standard kubelet running, and if I plug the cable, kubelet will continue to keep those existing workloads alive. Meaning if the pod crashes, it will get restarted. But of course, you cannot make any changes through the API. You can't deploy anything new or change configurations, which I think it's quite okay on Edge anyways.
Okay, thanks.
All right, and if you have any questions later on, I'll be hanging around here. I'll be at KubeCon, so just come talk to me if you want about Edge, Kubernetes, or fly fishing. Thank you.
Okie dokie.
DBs and how we run pod disruption budgets across multiple clusters. I am late. I have too many slides. Let's see how this goes. Okay, a couple of sentences about me. My name is Moritz. You can find me on GitHub as Molen. I'm a reliability engineer at Form3. I'm in the platform infrastructure business line. We manage Kubernetes clusters across multiple cloud providers in the data center. We manage network equipment in our data centers and a lot of stateful workloads such as CockroachDB and NUTS. I'm also one of the original creators and maintainers of external secrets. So if you want to talk about secrets management in general or all things reliability, just come around. The agenda for today, so before we dive into the cross-cluster pod disruption budget thingy, I would like to provide you a little bit of context about Form3, about how we run infrastructure. That's very important context for the problem that we're trying to solve here. And before we go into the XPDB thingy, I'll like to tell you about some the basics about pod disruption budgets, the eviction API, and all of that. So what is Form3? Form3 is a financial service provider. We're a B2B business, a bank-to-bank business. Banks generally want to send money, and we provide them a unified API so they can send money. We integrate different payment schemes, like FPS here in the UK, but also SEPA in the EU, and also a bunch of others in the US as well. So a couple of sentences about the infrastructure. This is like a really, really high-level overview of how our clusters look like. For us, we always run our clusters in a stack. That's what we call it. So here, each box is one cluster. One runs in Amazon Web Services, one in Google Cloud, one in Azure, and they're all connected with each other. So the pod networking is flat. Every pod can talk to every other pod. We have cross-cluster DNS resolution, so some pod in EKS can resolve a DNS record from GKE or an AKS cluster. And we also run a bunch of stateful workloads that are very important for our payment processing. One is CockroachDB, the other one is NATS. That's where we store our data and have our data streams. We do multi-cloud, so we integrate multiple cloud service providers, and also we run stuff in our own data centers. It is more complex than that, the reality, unfortunately. So we have this multi-cloud world here on the left-hand side, that stack of clusters. But there's another stack of clusters which are slightly different, but also similar. The vertical one on the right-hand side, that's where we have 2 clusters in 2 separate data centers here in the UK, or here on the corner, and also one running in EKS. And this is also a stack of clusters, but it's slightly different. And that stack on the right-hand side, that provides access to the payment scheme. That's where the actual magic happens. Of course, it's more complex than that because we run different, multiple environments, development, integration, staging, production, both in our multi-cloud world and also in our data center world. And also we connect to different payment schemes. In fact, for some of our biggest customers, they run on dedicated infrastructure, so they have their own stack, or their own stacks rather, where they then can do load testing in the staging environment or have their own production environment, and it's completely isolated and dedicated for them. It is more complicated than that, to be honest, because this is roughly what we run in the UK. We run more stuff in the US and in Ireland as well. But I didn't want to, prep a slide for that. That wouldn't make a lot of sense. So for today, we just need to look at that because that's the core unit we need to take into consideration. So about PDBs in general, that's what a PDB looks like. Can we do a quick show of hands who knows what a PDB is? Everyone? Mostly everyone. Good. Quick refresher on that. We have this max unavailable field. What does available actually mean under the hood? It means that a pod passes the readiness probe. That's it, basically. So when a pod is not ready, then it does not get more connections from the Kubernetes service object, and is not considered to be ready in the context of a pod disruption budget. The eviction API is just a simple Kubernetes API endpoint, which in the end terminates a pod. So it's similar to the kubectl delete pod API. But before the pod is terminated, the pod disruption budget is verified. And if that eviction would cause more harm and would violate the PDB, the kube API server would respond with an HTTP 429. So that would indicate to the caller that he's supposed to come back at some later point. Let's have a quick example here. So we have 3 pods on the right-hand side. All of them are ready and healthy, and I can try to evict the one on the left-hand side. That would work, no problem. If one pod would not be ready, the one on the right-hand side, and we try to evict the one on the left-hand side, that would not work because our max unavailable setting is set to 1. 1 is already unready, so we are not able to evict another one. Easy. If we were to evict the one on the right-hand side, that would work, simply because it wouldn't make the situation any worse. And as everyone knows, simply restarting a node, restarting a pod sometimes solves the problem. So we can do that without issues. But there's a little bit more to it. When you take a look at the Kubernetes documentation, you can read about voluntary and involuntary disruptions. Voluntary, these are the ones that are done by Kubernetes administrators, like draining a node, moving workloads somewhere else, or engineers who deploy a configuration change, deploy a new image version. That's that. But in terms of involuntary disruptions, there are many sources. Just recently, a month ago, Amit Balkan, I think he's a well-known figure in the Kubernetes community, he released a blog post on everything around involuntary disruptions, and I just grabbed this table from his blog. So go check that blog out. It's very, very helpful to understanding involuntary disruptions. As you can see, I hope you can see it, on the very top, there's this eviction API. That's where that's called when you use kubectl drain. That's like pretty much the only API call that respects the PDB, and most others do not respect that. So a direct pod deletion like kubectl delete, or a workload controller like a replica set controller, the daemon set controller deleting pods, they do not respect the PDB. However, they implement their own readiness checks, so they wouldn't cause any harm in a single cluster context at least. And a bunch of others like node pressure, priority, preemption. There are a lot of involuntary disruptions. So why am I doing this talk? Because it's not that easy if you have a multi-cluster topology where you run into issues when you have one workload spread amongst different Kubernetes clusters. Again, this is our world with this stack of clusters, one in EKS, one in GKE, one in AKS, and we have 3 replicas of CockroachDB running in each cluster. Now, let's take a look what happens if the one here in GKE, the CRDB2 pod, is not ready, and we're trying to evict the one in EKS here on the left-hand side where the arrow points at. That would work without a problem, because PDBs aren't aware of what is happening in this other cluster. Like, of course, how would it be aware of that? In our context, this is a problem because CockroachDB under the hood has a raft group. They have a leader election raft group implemented. And in this case, if 2 pods would go down, like 2 wrong pods that host this range 1, 2, 3 that is displayed here, in that case, you would lose the majority of your pods, and as such, you would lose the leader, and as such, this database range would not be available anymore. So, for us, that would be a P1 or P2 kind of incident immediately, because some database records are not able to be read or to be written to. There are a couple of contributing factors that you typically see when you have lots of movement in your clusters. That was like our major problem. Having like lots of clusters, you can work around this issue that I just showed you. But if you have like lots of changes coming from configuration changes or rolling out changes to CockroachDB or to Nats, or if you do regular node maintenance, I guess everyone here does regular updates to the nodes, updating the kubelet, the Kubernetes version, updating the kernel and all of that. We do this like on a regular basis, and our development and integration stacks, we do this like once a day. Like all that movement kind of contributes towards that issue where you potentially just shoot the wrong pods and then you have an incident that you got to resolve and work on. On top of that, we run a bunch of more stuff, chaos experiments, we do incident rehearsals like every week, and like a bunch of other stuff that can happen to your clusters that could make the problem just more prevalent. How can we fix that? Well, we can just coordinate and communicate and manually check the state of our workloads before we deploy configuration change, before we drain nodes. But this is really a big pain, and it doesn't scale with the number of clusters, it doesn't scale with the organization. We tried this in the past and it didn't work. It never has worked, and the whole process was just doomed to fail. So we automated that away and made that work for us. So what we really wanted is a pod disruption budget that spans multiple clusters. So in our perfect world, we imagined, if we try to evict the pod here in EKS, the middle one, CRDB1, we would just be able to somehow block this eviction from happening because we need some mechanism that is aware of all the replicas of CockroachDB across all the clusters. That's what we did. Pretty simple and straightforward. We open sourced this tool. You can take a look at it. Unfortunately, InfoSec doesn't allow us to provide contain images for you, so you got to build it yourself, but at least that's something that you can take a look at if you also suffer from the same problem. Maybe we can do a quick show of hands. Is anyone here suffering from like multi-cluster topologies, or are we the only idiots? Oh, you too? You too? Great, great, cool. That's why you're here. Cool. I'd like to hear how you manage these kinds of problems. It's a real pain in the ass. Okay, so what did we do? Essentially, we hijacked the eviction API by using an admission webhook. So whenever there's a evict pod API call, we would just hijack that, take a look at all the replicas in all the known clusters, and then we can make a decision, either thumbs up, yeah, sure, you can delete or evict that pod, or thumbs down, and respond with the same thing, HTTP 429, please come back later. Yeah, that's it in a nutshell. When we take a closer look, we also implemented our own custom resource. Here on the right-hand side, the X pod disruption budget, which is like a cross-cluster pod disruption budget. And as you can imagine, it looks pretty much like a pod disruption budget, but is aware of all the clusters and all the pods. And we have added a bunch of extra fields, which we might come back to later. So how does it work in detail? Looking at the left-hand side, so when something calls the eviction API, that could be a kubectl drain, that could be some operator that runs in your infrastructure that manages and maintains your node pools and moves the workloads off to other nodes. Now this eviction API comes in, then this admission webhook is sent to XPDB. That's our controller that runs in every cluster. This is a controller and is a webhook server, so it receives that admission webhook, and then it fans out to all the known clusters and says, okay, look, what is your state of the world? How many replicas are you supposed to have? How many replicas do you actually have? And how many of them are ready? These are the 3 key things that we need to know from each and every cluster. And with that, we have all the information, all the state of the world to file a verdict, and then can say thumbs up or thumbs down to that eviction call. It is slightly more complex than that because we need to deal with a race condition here. Potentially we can evict one CockroachDB pod in EKS and simultaneously in GKE as well, and potentially like in all the clusters. To work around this issue, we've implemented a locking mechanism so that whenever a admission request comes in, we acquire a lock that is under hood just a lease object, and we hold this lease, which is specific for this admission request, that is specific for this particular workload and this particular namespace. So we hold this lease for 5 or 6 or 7 seconds, and then we fan out and ask the other clusters, hey, what's your state? And then they themselves also acquire this lease, acquire this lock, and hold it for 5 to... Are we in power saving mode? Okay. And then they themselves hold this lease and send the response back to the original caller, and then we send the admission response back to the Kube API server. There's a little bit of overhang, so we hold the lease slightly longer than the admission webhook is in flight, because when we return the response to the admission webhook, we still got to hold the lease because the Kube API server is still processing the request, and there's still a potential that a race condition could occur. Yeah, that's what we did. So in this case, again the same picture. So one CockroachDB pod here in GKE is unavailable and trying to evict one pod in EKS. We would just simply block that because of what I just told you. There's one more thing to note here. We have this X pod disruption budget deployed to each individual cluster because there's no concept of like a cross-cluster custom resource or custom resource definition. That just doesn't exist, so we cannot have that. Instead, we have one XPDB resource deployed to each individual cluster. What about involuntary disruptions? I showed you the table earlier, and only the PDB was respected in the eviction API call. So direct pod deletion would not respect the PDB, but in our use case, if a replica set would trigger a change in EKS and something would be unavailable in GKE, it would not be aware of that. So we also have to take care of the pod deletion API call. So we also hook into that one and implement the very same logic here. So in the end, we end up with this table here where the PDBs are respected in every case, in every pod deletion, when there's node pressure, when there is a preemption due to pod priority, we all block those. That's just based on our requirements because we cannot delete a particular pod that is part of a RAF group. In CockroachDB, we just need to prevent that at all cost, basically all cost. This has been running in production for about a year now, so it works with that configuration. Actually, for the preparation of this talk, I just revisited that. I reflected what we've implemented, and I found like, damn, there's still this node deletion garbage collection going on. Is that a problem if we cycle the nodes, but we have this pod disruption budget? But apparently it's not a problem. It's fine. So feel free to try this out in production. It probably works. What could possibly go wrong with this? So as with every admission control webhook that you have, there are a couple of issues that you need to take a look at. One is if the admission webhook server is unavailable. So if XPDB is unavailable in a particular cluster, we would block every call to the eviction API and every call to a pod deletion. So that's not a place that you would like to find yourself in, because that could potentially lock you out of a cluster or cause some other issues. We've worked around that problem by implementing label selectors on the admission webhook resource, so that only specific pods from specific namespaces are subject to the interception of the pod deletion and pod eviction API call. So only if a pod is deleted in the CockroachDB namespace, like we care about it, and everything else, kubesystem namespace, we do not hijack the eviction and pod deletion API call. And there's a second failure scenario where the remote cluster's XPDB server is unavailable. In that case, we just need to manually take a look at the state of the world and see if we can fix that temporarily, or we want to take that remote server out for maintenance. Just in case there's a regional outage or some bigger issue with a particular cluster, we just need to take it out of the equation when taking a look at the disruption budget and take manual action on that. That has never happened in production, and hopefully will never do. And there's also some field that we've added to the XPod cross-cluster pod disruption budget resource, which is a suspend field, which is similar to the Flux suspend field, where you can just simply disable that resource temporarily. So in a local cluster, you can then continue to delete pods if you're really sure that this does not cause any issues. All right, there are a couple of more things on this topic which have previously been presented at KubeCon. One talk by Ilya Chekrygin. He also has implemented a distributed pod disruption budget thingy. Unfortunately, it's not open source, but definitely worth a watch, that talk, and also some talks related to how to carefully replace nodes across multiple clusters that helped us to optimize our node management. All right, so if we're lucky, we can get this demo running. Let me see. Oh no, I cannot move it. There we are. Oh, we are not. All right. All right. Let's just pre-record it, so, all right. Oh, it does not work. Oh no. Oh no, oh no. Let's see if the scaling works now. No. That looks okay. Okay, so on the right-hand side, you can see GKE. On the left-hand side, you can see EKS. So we have CockroachDB, 4 pods in each cluster. So on the left, at the top left-hand side, I tried to delete a pod in EKS. On the right-hand side, in GKE. I tried to do this simultaneously. So I trigger the pod deletion in GKE, and it goes into terminating state. And on the left-hand side, let me pause quickly here. You can see that XPDB denied the request because we cannot disrupt this pod because it's unable to obtain the log. So this is pretty much that race condition that I've talked about. So that prevents that pod from getting deleted. Now we can just try to delete the pod every 2 seconds, and we can see a similar error message now where it says we cannot violate the pod's XPDB disruption budget. So on the right-hand side, you can see in GKE, CockroachDB 0 is about to come up. 2 out of 4 containers are ready. The pod is running and should be available soon. And as soon everything is ready again, on the left-hand side, we should see that CockroachDB 0 gets deleted in just a few seconds. All right, so CockroachDB 0 is now terminating. And now let's try to delete it in GKE again. And as you can see, we cannot do this because it's in terminating state, so it's not available. And with that, that's it from me. Thank you very much. Are there any questions?
How do the XD or the cross-cluster PDBs instances in each cluster communicate with each other?
How? They use gRPC to.
So they have to go via ingress or flat network or something
We
like
have
that?
we have flat pod network between the different clusters, so they can directly communicate.
Can you configure it that you don't need a flat network, that you have something like over dedicated load balancer communication?
Yeah, sure.
Okay,
Yeah.
it's not
just it's just a TCP port that runs
Okay.
gRPC, and then you can just have your load balancer or make it public. Do whatever you need to do to make it work. Yeah.
I mean, yeah, public internally.
Yeah.
Okay, thanks.
Yeah, sure.
Any more questions? Yeah.
Have you considered trying to using something like etcd in favor of the leases to actually hold the log of hold the distributed log across the clusters instead of relying on native Kubernetes objects?
We haven't considered it because we are running a managed control plane. So we run just EKS, GKE, AKS, and everything is managed, and we don't want to or need to run etcd on top of that. It's quite complex.
You don't want to deploy your own etcd, it would have the same problem as the CockroachDB, basically.
Yeah,
right?
That's true. Yeah, that's true. Yeah, sure. Sure. It's a stateful workload then as well. Though it can be cluster local, so it's not that you have I guess you can have different topologies. There are multiple ways to do it. But yeah, I would rather not have another stateful workload that we need to manage, and I don't even know what the state of etcd operator is. I don't think it's maintained anymore, so it's not as simple to run etcd simply.
Okay. Yeah.
Have you tried to get these changes upstream into PDB?
No.
Because it might be worthwhile.
Yeah, so we took a look at some alternatives, and all of them pretty much involved to disabling the PDB controller, and this flag is not available with managed Kubernetes that you have. So in EKS, GKE, AKS, you just cannot configure that field, because then we could have implemented our own controller and make it aware of everything across multiple clusters, but so we don't have access to that. Not sure if it's worthwhile to implement it, honestly.
Yeah, just maybe if they could somehow make it a little more extensible so that you could kind of plug things like this into it, might be worth considering.
Yeah.
Alrighty. If there are no more questions, so there is a break now until 4:35, and then there is going to be the last talk in the Waterloo.
Thank you.
Well, welcome everyone to our talk on the Infinite Hotel, scaling multi-tenant platforms through a unified API. Let's first, of course, introduce ourselves. So I am Carlos Mestre del Pino. I'm a KCD organizer in the Netherlands, and I'm going to use the moment to say we have a KCD coming up on the 3rd of July in Utrecht in the Netherlands, of course. I'm also a cloud solution architect in Microsoft, where I help Azure customers with getting up to speed with Kubernetes, scaling a little bit their platform operations. And yeah, you got there. I'm Mestre del Pino on most, no, I believe in all socials. And of course, you got the QR there if you want to visit any of my links.
Yeah, hello everybody. I'm Chris. I'm working in Upbound as software engineer, taking care of developer experience for Crossplane. And yes, Crossplane is our popular open source project. And with Upbound, we built an enterprise software around obviously Crossplane, right? And we really leveraging Crossplane here and going with the control planes on scale.
So yeah, first just a small disclaimer, because we've been using some supporting materials from this YouTube video, which is the Infinite Hotel Paradox. We will be talking a little bit about it now. And well, this is the kind of like inspiration that we got. We're just using some of the images from there. The alternative was to like do some like ChatGPT generated Studio Ghibli images, which are very on the topics today. But yeah, because I discovered this paradox through this video, I wanted to give a bit of credit as well to, yeah, well, to Ted and to Jeff Dekowski. And please, there's a link as well in there if you ever are curious about the rest of the paradox. So just to set the scene a little bit, I'm going to give a bit of an introduction on the Infinite Hotel Paradox, or also known as the Hilbert Paradox of the Grand Hotel. It was created by David Hilbert on 1925 lecture. It was first introduced. And it demonstrates how a hotel with infinite capacity, that it's full, might still be able to accommodate some guests. It was made for humans to try to wrap our heads around the concept of infinity, given that humans are very, very bad with extremely large numbers. And well, in this situation, there's a hotel, like I said, it's infinite, it has infinite rooms, it's full, and there is a hotel manager which uses math to solve problems and be able to accommodate more guests. To give a bit more context before moving on to our infinite hotel, this is just a couple of the scenarios that we see. So say that you have the hotel with infinite rooms and it's entirely full. How do we accommodate one new guest? Well, in this case, the hotel manager would just ask all the guests to move to the room n+1. So if the guest in the first room will move to the second, the one in the second moves to the third, and so on, which vacates the first room. Then it goes a little bit deeper. So what would happen if now we are receiving an infinite amount of guests? Well, the hotel manager, once again, with his math knowledge, says, okay, let's just take everyone to the room 2n. What that means is that the person in the first room will go to the room 2, the one on the 2 to the 4th, and so on. What that does is that it vacates all the uneven number rooms, which, of course, there are an infinite amount of them, and therefore we can host an infinite amount of guests. Goes a little bit deeper into deeper mathematical concepts, which I will not go too much into because that's not what we came here to talk about. But it also talks about the scenario in which you might have infinite ferries, each of them containing an infinite amount of buses, and each of these buses containing an infinite amount of people. So it's kind of going deeper on the levels of infinity, kind of nested, which is as well the way that we're building our platform sometimes. So with all of this said, we need to, well, I'm going to give you some of the, let's say, what do you call the setup for our infinite hotel, which we will be also talking about, well, demonstrating a little bit later. So Of course, we are trying to provide infinite capacity in the hotel, and now we are talking about cloud resources, so that's why we're quoting the infinite. We cannot be as vast, let's say, as if we were just talking about mathematical concepts. We also have our hotel manager, which in our case, it's our control plane. It's quite important to mention, even before, based on the paradox, it's not only about having the infinite capacity, but it's also about having someone who has the knowledge of, in this case, in that case, mathematics, so that they can accommodate. And in our case, our hotel manager is using platform engineering principles to scale infinitely. So now let me talk a bit of what would we need in such infinite hotel. So, of course, first thing that we will need is an infinite amount of lobbies or buildings which will be able to host our infinite amount of floors. And then in our floors, we will be putting our rooms, which can finally, of course, accommodate the guests. But as any other good hotel, we're not only providing the rooms, we're not only providing infrastructure, but we're also providing some supporting services. And in our case, we have a gate guard, or any infinite amount of them, to ensure that guests are only allowed in their respective rooms, right? So that they are not able to get into someone else's room. We also have a concierge service, or any infinite amount of them, which will bring the guests' belongings into their rooms. So how are we defining this? Is, of course, as Kubernetes custom resource definitions, or in our case, with cross-plane compositions and composite resource definitions. That allows us, of course, to define everything, everything with YAML and with some functions. And now I just want to show you some of the things that we define. So, for example, for the lobby, we have it very basic at the moment. The lobby will represent a network, a VNet. All of this is deployed in Azure, so that, of course, maps to the VNet. And then we are just setting something in here, so like what wing it's on. In our case, we chose West US. We're trying to scale up infinitely, so we wouldn't be using Azure West Europe. Then, after we have our lobbies, we are able to build our floors on top of that. Our floors will be, or each floor will be an AKS cluster and some supporting services, which we will show later a bit more in detail. Some of the parameters that we're setting in here, so we're setting what lobby the floor is related to, so on top of what lobby it should be built. This is, of course, the network for your AKS cluster. You can also see that we also have the wing there in the region, but that's also something that could be directly inherited from the lobby, and we have some more examples of how that happens later. And a few more things like the occupancy permit, which in our case is the Kubernetes version, or the AKS version for the AKS cluster. And we have as well something related to the sizing of our floor, which we have a count, so for number of nodes. And we also have our room class, in this case basic suite, which will map to different VM sizes. We then have our rooms, where we can finally start accommodating our guests. And as well, we decided to leave it simple right now for this use case, for this demo. And of course, we're just saying in what floor we would like our room to be. You could also add some other parameters related to the sizing. In our case, the room, it's a loft vCluster, which gets deployed onto an AKS cluster. So of course, that goes on a given namespace. So if you wanted to do anything related to sizing of your rooms, you could use resource quota, you could use limit ranges. So that would be a way as well how you could limit the size of your rooms. Next to the infrastructure, of course, we have the services, and we will have a gate guard as well, which in our case is Keycloak, and it will be, of course, providing the access into the rooms as well as providing the access to the concierge service. In here, we're only setting up the lobby, so we have a one-to-one relation at the moment with gate guards and lobbies. And of course, we will give it a name as well, which will relate to the ingress that will be created for that KeyCloak instance. Next, we have our concierge, which is Argo CD. Of course, the concierge is there to take the guest belongings into the room. And as well, similar to the setup on the gate guard, right now we're just saying on what lobby our concierge is operating, and as well a name for it so that it can be accessible from outside. And of course, a hotel wouldn't be anything without their guests. So we also have a resource definition for the guests. And some of the things that we're setting in here, of course, again, on what lobby. We are not currently limiting per room, so a user may be able to use a different number of rooms in the way that you might use different clusters of different environments. In here, we will set things like, of course, information about the user. So what's the username, last name, first name, an email. We'll set up a group, which will map to the OIDC groups provided by KeyCloak. And of course, we will have an initial password, which, or we need to make a reference to initial password, which is just on a Kubernetes secret. So how does all of this piece together? I will first show you. I will first show you a little bit about our hotel manager, and then I will move on to the architecture of our hotel. So this is our hotel manager, which, as I said, is one of the most important elements in the setup. Without the hotel's manager, let's say, platform engineering knowledge and capabilities, we would not be able to manage our hotel. So the components in our hotel manager, we have, of course, a crossplane deployed into there, and then we have as well the providers and provider configs. We are currently, or for the demo, we are currently hosting it in an outbound control plane, but you could deploy this into an AKS cluster as well. In here we have our controllers, so those are the providers, so that we will be able to create resources outside of Kubernetes with Crossplane. And we have one for KeyCloak, of course, Azure, and then we'll also be deploying both Kubernetes resources, bare ones, and through Helm charts. We then, of course, need to provide the access to those APIs, which we're doing with the provider configs. And this is the way that we have it set up right now. Of course, it could be more flexible, but in any case, for the first one, with the KeyCloak, well, for each KeyCloak instance or for each gate guard, we will have a provider config. Then we will also have an Azure provider config per subscription, because that's the way that the provider is working, and then per floor, so per AKS cluster, we will be configuring a provider config for both Kubernetes or Helm. Now, this is because we are not currently deploying any Helm chart or other resources as such into the rooms, but that's, of course, something that you could also do, or you could have, of course, both, because you might need to manage resources on both the AKS cluster and the virtual clusters. In terms of our hotel architecture, you can first see that we have our lobby. It's a little bit zoomed in, but we have our lobby perimeter, which is, of course, our VNet. We're then placing our AKS cluster in the VNet, as well as the supporting resources, which you can see in the top left. That's an NGINX ingress controller to provide the ingress into the Argo CD and KeyCloak instances, as well as for the rooms, so the virtual clusters. That is integrated with Cert Manager and a cluster issuer using Let's Encrypt, so that we can create SSL certificates based on our domain name and inject them, let's say, at the ingress level. Then, of course, we have our room, so that's the V cluster in there. And we also have our gate guard and concierge. They're currently deployed in the same floor. If you had a different setup that you're not mapping to one floor, you could have that as well on a separate kind of like shared services cluster. So with that said, we now have our guests, which can give their belongings to the concierge, and they can also go through the gate guard in order to access their rooms. There's also another icon in there of a server, of someone in the hotel, which is providing the room service, let's say. And what we're doing in here is creating certain service or Kubernetes deployment and service onto the host cluster and allowing it through to the V cluster. So that's our room service. In our case, our guest ordered a paella, and I hope they really like it because it's going to be an infinitely large one. Yeah.
So now it's me. Okay. Yeah, I'm working with crossplane and infrastructure since years, right? And I want to give some nice input what I learned in environments, right? If you really want to build like an infinite platform with like you're scaling a lot of virtual clusters, you're scaling Kubernetes clusters, and what are the challenges, right? So at the end of the day, what you really want to do with the scaling of the platforms is you have multiple layers which are really interesting here. So security, the management of all this kind of components, and something like your service architecture at the end of the day. So how many controllers from what you want to host on which layer of this platform, right? And yeah, in a bit we will unpack like all of these aspects here and talking a little bit about this. So again, a vision when you're building this kind of platforms is something like you want to be modular, you want to be like multi-tenant, you want to be running like multi-control planes baked by crossplane, for example. And the thing what you're trying to do is you want to unify like your infrastructure deployment, but also the application deployment inside your infrastructure. And then what you need to do is, if you want to achieve this vision, we have a lot of challenges, as I said, right? So we have the security and workload isolation topic to solve. We have scaling challenges. We have shared versus centralized service scaling. And we have something like service to infrastructure mappings when we're building this kind of infrastructure, right? So first thing would be security, right? And security and keeping workloads isolated can be really, really complicated fast in your platforms, right? Because if you want to leverage multi-tenants in your platforms, you need to isolate this tenant somehow, right? Perhaps the easiest part is like network isolation, so you're switching on some network isolation features. But thinking about if it comes to crossplane, right? Crossplane has today like provider configs that you can interact with other APIs with your cloud providers, and these provider configs are cluster scoped. So if you have multi-tenants now running on the same control plane, same cluster with crossplane, what you want to do? What I'm seeing as a pitfall in a lot of environments is something like the platform teams allowing their consumers to set as an input parameter the provider config, but that means like everybody can consume all your provider configs. And it's the same thing if it comes to something like connection secrets, right? If you're spinning up a Kubernetes cluster per default, right, you're getting cluster admin connection secret back. And if people are allowed to use all your provider configs, then you will see that tenant isolation is not really working anymore because I can grab it and can start rolling out some things on top of it, right? Yeah, and that said, the other thing is around what we're seeing relatively often is people then starting to think of isolation with our rooms here in the hotel is like, cool, we're spinning up like vCluster in the Kubernetes cluster, so we have more isolation, but this also leads then to more crossplane installations, more providers, more something, and you can also miss up like a lot of configurations in the vCluster if you're not setting the right settings for the network isolation, for example. Then it's perhaps like your workload is isolated, but under the hood you can like connect between each others from the controller perspective. The next thing would be if we're talking about scaling, right? And at the end of the day, scaling isn't magic, right? It's your architecture at the end of the day, right? So when we're talking about these scaling challenges, we need to also look at like 3 key areas. So if it comes to control planes, you need for scaling, right, you need to ensure your centralized components handle increased load, right? What does it mean if you're now running hundreds of crossplanes, hundreds of providers, hundreds of vCluster services, right? So under the hood, you can scale relatively easy with putting in more resources and so on. But on top of it, what you need to configure now on the individual services, right? And that's like relatively hard to do. The other thing is management overhead, right? So if you have now thousands of containers running, then your platform team perhaps has a lot of things to do to taking care of individual versions, taking care of all of this kind of providers, right? And yeah, the other thing is state management across clusters. What I'm seeing relatively often is that people spinning up like workloads from one of the other cluster, and if the control loops are not working great, right, then you have state here and state there, but they're not connected anymore, and you need to like figuring out what does this mean at the end of the day. So the next thing would be shared versus centralized service scaling. So it was interesting when we built up this demo here. Carlos asked me like, Chris, why we have only one concierge Argo CD deployed now? I would expect we have this in every room. Everybody gets his own Argo CD. And then I asked like, okay, do you also want to like deploy now everyone a key cloak in the room? Yeah. Or what is the idea, right? And what you really need to figure out then is like you need to mapping your services to your right infrastructure, and you need to figure out what all kind of things, what you try to build, right? Because these are technical details, but you have strategic decisions perhaps at the end of the day in your company, and how many of these controllers you really want to host. And if you have in the company the idea of we want to have a centralized one, then the platform team needs to figure out what it means, right? So you need to do something like pilot deployments from this infrastructure components, right? You need to figure out like how is the behavior in your controlled environment. Like the other thing is like load testing. So you need to simulate real-world conditions. What we're seeing relatively often is that people like running crossplane, and then with like hundreds of resources, everything is fine, but with thousands of resources and a lot of more controllers, they have like problems that they can run this. The other thing is you need to figure out like all this kind of things. So what is your high availability? What is your performance? And what is at the end of the day your quick recovery after a failure, right? Can you spin up something in parallel new? Do you need to configure like state migrations between? All this kind of things you need to figure out if you're running this kind of platforms. The other thing here is, again, service to infrastructure mapping. So for example, we talked about when you're having a key cloak and you're having an Argo CD and you want to have now configurations for OIDC that people from your infrastructure can log into your Argo CD, right? How you configure this with the key cloak side, everything, or do you allowing like self-service? And if you're allowing self-service, does this mean everybody can reach your key cloak and doing some configuration changes in your key cloak? So you need to figure out a way to stop like configuring everything in your key cloak, and that's like really important. And I would like really happy to chat with some folks how you like limiting the access to this kind of APIs, right? If you're running in this kind of multi-cluster environments. And then the other thing is like, as I said before, number of instances, but also like it really depends on how many distribution you're running of your services. You need to understand your load characteristics again, your replication needs, all this kind of ideas you need to figure out. And then, if this strategic, if you're matching like all this kind of things for today in your platform, right? And you're figuring out like all this kind of things I was talking about, then you also be very well prepared for the future, or if you have unexpected loads on this platform. That said, at the end of the day, it's all about scaling challenges, and if they come down, it's all about like strong API design if you're building the platform, right? So if your APIs needs to be designed for like flexibility, for composability, and for like clear contracts, means if you're building like an Argo CD today, right, what is your contract? Deploying it to a Kubernetes API, and then it doesn't matter if it's like in AWS, EKS cluster, an Azure cluster, in vCluster, whatever, right? And you can scale whatever this means, right? And and then scaling becomes your architectural choice and rather than an afterthought. And it's the groundwork of your platform if you're doing the things right and thinking about like all the scaling things. Cool. I think we have like 4 minutes left. Let me try. Sorry. What's now? The entire screen. So I want to share like one thing, if it comes to like cross-plane projects, and I want to like highlight what I'm seeing in a lot of cross-plane setups. So if you're creating like all your APIs and pushing it to an OCI registry, you can relatively easy like get automatic API documentations, right? But a lot of people like creating their APIs without descriptions, without input validations, without nothing, right? Then you see something like this. So you have no idea what is the gate guard, what is the lobby, what is the name. There's no description, no nothing, right? So if you're building platforms for infinite scale, please, guys, starting to document using the API server for automatic validation from your input with CAL, with enum support, all this kind of stuff, right? Because if you're not doing this right, then you cannot scale for infinity because like you need to like help all your customers to like onboard on this platform, right? The other thing is, yeah, I think you can see this. The other thing is what I relatively often seeing that people like installing like something like this. So all versions bigger than like 000 means like at the end of the day latest. If you're installing latest means you have like one cluster here in this version and the other cluster here in this version, and in your vCluster setup another version. So please use like a specific version and then use something like Runaway to update all your components here. The next thing what I relatively often see if people are building this kind of platforms, they have mono repositories, so everything is together versioned, relatively bad. So as an example here, you see our full hotel here is in a mono repository. Everything gets a version number together, and then it's relatively hard to only like updating like a specific service here. The other thing is what I'm seeing is in this example, you're seeing tests here. So we're having here composition tests, but we don't see some kind of end-to-end tests, right? And for example, I was reading like a blog post from Grafana the last days. Without end-to-end test, you can relatively easy like mess up, for example, a Kubernetes service, deprovision in load balancer, and then you're fucked, right? Because you need to figure out then how I can get the load balancers back, how I get the services back, and all this kind of stuff. So please, like running end-to-end tests here. The other things which are relatively interesting here, if you're going a little bit deeper in the codes, I'm seeing relatively often that people using a lot of hard-coded stuff. So something like this, crossplane IO / claim names, it's fine. If you're running like a single tenant to use claim names, right? But if you have multiple tenants, you have claims in multiple namespaces, but at the end on the cluster level, it's the same name. So you have name clashes. You're perhaps giving like resources to other tenants in your platform. That's like relatively bad. Yeah, and all kind of this stuff we have a Git repository open. We're sharing this here, so you can have a look afterwards. So we have a lot of things here which is bad under the hood, but you can start with it and like enhancing this. But if you're running this directly today, you will never like get an infinite scale from your platform because there's a lot of open points inside. So then, yes, that's for you. 30 seconds.
Ooh, thank you very much. Well, I think I can wrap it up in 30 seconds. So we're just straight to the point with our key takeaways. So you must test your platform components, your platform component limits and scaling before finding out during operations. So again, this kind of reinforces a bit the planning, the design, right? And just like trying stuff out before you go and deploy it, because you do not want your platform to break and then you're going to have to fix it after in production. Then the architecture, as Chris well mentioned, does not only solve technical challenges, but also strategical and organizational. So it's very important to know the way that you're going to be distributing your instances, and are you giving something for a tenant, or is that being shared, right? So you do need to understand what you actually need to achieve before going and deploying a platform like such. And of course, starting with the wrong decisions will make you firefight. So again, testing, testing, and testing. Thank you very much.
Thanks, Chris, Carlos. So the next session is at like in 5 minutes from now in the Nash. So we'll have like a few questions before the time runs out. Any questions? Yeah. Okay, so you have about 5 minutes to get to the next talk in the Nash. Hope you enjoyed the sessions today. See you.